Good morning. You can all start taking your seat. It's really good to see so many of you, really a lot actually coming back. It's either the food or the company or it's the stands. And I do want to check in again with you. How people, raise your hand if you visited by now more than 5 stands. Okay, better, sort of half of the room. So you still have until 4 o'clock today to make that a better figure for everybody, yeah? Okay, again, as I said, very good to see so many of you. We start this morning with a session led by Romerik. Romerik doesn't need any introduction. So Romerik, I pass the floor over to you.
Yeah, now it's working. Okay, yeah, it's really good to be with you this morning again. So you saw me yesterday. I'm Romaric Redon. I am the Chief Operating Officer of Vanity. And my pleasure today is to welcome a wonderful panel, which we have around the topic of flying with AI. So how AI can provide assistance for various tasks. And I think yesterday I had the chance to give you an overview of some of these tasks, and today you will see even more tasks linked to the different type of AI which we can use. So things which are linked to computer vision, time series analysis, also the use of some generative AI, and also optimization aspect. So all of that in a panel where we will go from we have a wide variety of actors, starting from startups up to well-established aerospace leaders, also airlines, a different type of airlines with us, and also the topic of really environmental sustainability linked to contrails, which will be presented by EUROCONTROL and TU Delft. So I won't go in a full introduction of each of the speakers in order to manage sufficient time for Q&A. I really entice you to prepare these questions because I think they deserve a lot of questions given the high quality of the content they will show. So we will start with being inside the flying machine somehow. Starting with collision avoidance, then moving in the cockpit with different aspects linked to pilot assistance and the pilot physiological monitoring. Then we'll go more with the airlines viewpoint and finish with this challenge of detecting the contrails and potentially in the future avoid them to some extent. So that's the menu. I think we are pretty good. Just gender diversity is a bit of a challenge for us, but it's the challenge for all of us on AI. So we may try to improve it next time. So then I think we will start now directly with calling Christophe Skilleros from Hellenic Drones. The floor is yours.
Hello, good morning, everyone. It's a great pleasure to be among you and present our technology. So what I will present today is an automatic system for detection of non-cooperative aircraft in order to facilitate the more autonomous aircraft. Okay, great. So the motivation for this technology comes from the fact that in order to fully leverage the capabilities that the concept of advanced air mobility can offer is the fact that we need to change the one-to-one ratio between each pilot controlling each aircraft in the sky. So from our understanding, one major bottleneck in order to achieve this is to manage non-cooperative aircraft, because as regards cooperative traffic management, there is a lot of established and well-proven methods to do so. However, for non-cooperative aircraft, there are not many automatic methods to do that. So what we are proposing is a method that is based on computer vision technology that leverages inputs from optical cameras that can be strategically located around any type of aerial vehicle. And their feed is processed on board the aircraft. And the outputs of this processing streams is either transmitted initially to a ground station, and while the autonomous level increases, it can be directly transmitted to the aircraft mission computer to proceed with collision avoidance tasks. What is needed from this processing unit to do by receiving the inputs of the cameras is to detect and classify the types of objects it sees in the sky, provide unique track IDs in order to know which vehicle is at each time relevant to the information. Try to estimate the distance between the own ship and the obstacle, identify the relative direction and movement of the detected vehicle, and based on all this information, create a collision warning that can be provided to the operators or to the mission computers. So a short representation of how this system works and what it does is through a small series of video clips that shows different types of aircraft, either small drones, either general aviation aircraft, either helicopters, where are or approaching or moving away. And the system is able to do all the stuff that I mentioned previously and provide some kind of collision estimation warning to the operator. So all these functionalities, as I will explain in the next slides, can be further increased and can be further refined. However, this is a position that we stand right now, and this is what the system can offer at the moment. In general, what we can do right now is that we can accommodate up to 8 cameras, which not all of them can be processed simultaneously. At the moment, we can process simultaneously up to 2 camera feeds with a processing speed up to 7 Hz for each stream, while if you have only 1 camera, the processing speed is up to 14 Hz. Then, depending on the user needs and the user strategy, any number of cameras can be used, which can be processed in series and provide the results in a lower speed. The performance of the systems in terms of the range and the type of aircraft that can be detected depends on the focal length of the lens that is used. This is purely a physics-based calculations, and on the size of the obstacle. As you can see, general aviation aircraft can be detected between 3 kilometers up to 17 kilometers, while small drones from 230 meters up to 1 kilometer. In terms of our design philosophy, we prioritized the concept of being hardware agnostic because we acknowledge the fact that there will be continuous involvement from sister integrators. So we need to be able to work with any type of computing unit or camera that any user will use for other kind of applications. However, we believe that the best way to do this kind of tasks is through graphic cards. So our system is optimized for GPUs, which we believe that offer faster development and consequently faster time to market. And finally, the architecture that this system is based is modular, which means that not only it can be easily upgraded through the more efficient algorithms in the computer vision community, but also it can work very easily with other systems such as radars or more traditional ADS-B or TCAS methods for cooperative traffic management. So, in terms of the operating conditions, where this is a bit more interesting in the and leads to the uncertainty for the certification. First of all, the system works during normal flight conditions. So in during takeoff and landing cases where obstacles are very near, it doesn't make sense for this system to operate. So it's not operational at these cases. As regards the data sets used for training, as you can imagine, most of them represent daylight and like almost perfect conditions. I mean, there are cases in real life that include some kind of low cloudy cases or fog, but they're the minority of the data sets. In order to accommodate and create training data that can represent more the real world, for example, include weather variations or sensor or camera noise, we created simulated data set using mathematical methods to create out of distribution data that can emulate these kind of corruptions, either environmental or hardware. As regards our roadmap and what we want to do, we started this this project in the beginning of 2020, and after a few years, we are at a stage that we can expose this to early adopters or interested users to get feedback from the industry in order to understand how we should direct our development process from this point forward. An important checkpoint before we are able to reach full maturity and commercial readiness is the certification, which is an important barrier for everyone that develops this kind of systems, but more importantly for us that develop a system that is heavily based on AI, which has the inherent problem of uncertainty. Thankfully, the regulators have acknowledged this issue and the growing demand for AI applications, and have released guidelines and are working very actively in that direction that we follow very carefully. And we have just started this process, which we believe that it will take a few more years before we are able to reach some kind of DAL certification. Challenges that we consider, which I have put in this list, which obviously is not an exhaustive list, and I would like to hear your thoughts on what we should add also here, is some kind of performance improvements in order to balance a trade-off between correct predictions and false positive. The tracking robustness, especially when you use multi-camera systems in order to keep the continuous tracking of an object moving from one camera to another, and the potential for this to scale up for not just two cameras, but more of them. The classification of aircraft type, which is a major driver for the distance estimation model, because it signifies the size of the obstacle. Increase the distance estimation accuracy, because as you noticed, the way we do it right now is to have some kind of distance ranges and not a specific number, which is very difficult, and I don't know if it's actually useful in the end of the day. Also, to understand a bit better from our industry partners what kind of information they need for to facilitate a collision avoidance logic, and also how this information can be fused with cooperative systems in order to balance the correct predictions and false positive by combining information from non-cooperative with cooperative systems. Increase robustness regarding out of distribution data sets. I mean, I described previously that we try to do this by creating simulated data sets that emulate edge cases or cases that are difficult to collect real data. However, as I heard very correctly also yesterday, this is a big challenge of how you are able to increase the trustworthiness of emulated datasets. And finally, as I mentioned also previously, all these elements will lead to will help us to create our case to certify this this system. So in a nutshell, this was our an overview of our technology. I would be more than happy, and I would encourage you to visit our stand outside to discuss even more specific parts that you would like to learn. So thank you very much for your attention.
So now we will move on we will move inside the cockpit somehow to see how AI can provide assistance for various tasks and how we can make sure also the pilot is still awake for following what is happening. And so I call Isham Atassi from Honeywell. The floor is yours.
So hello, everybody. I'm very glad to having me here. I'm going to introduce our project, which is funded by SESAR. It's called Darwin, and we are aiming at developing scalable human AI collaborative system for advanced operations. How to go to the next slide? I'm trying. No, not this one.
That one.
Oh, okay.
Yeah, that's.
Okay. Okay. So again, we are grateful for SESAR 3 joint undertaking for funding this project or jointly funding this project. I would start with like more broad approach or image of what drives the current aviation research and development, and we are aligned with it. This is our point of view. So we are speaking about autonomy, digitalization, and AI trust. So in terms of autonomy, because of the rise of air traffic, its complexity, the changes in terms of like the pilot age groups, and also the higher demands on the number of pilots, we definitely need more pilots. And in that case, we need to help them and bring some kind of autonomy to push the research forward, or let's say the operation forward. Yeah. So on the other hand, the digitalization, taking into account, you know, like in these days, the data is basically the fuel of AI and machine learning, and we have a lot of them. We need to store them, we need to process them, and also this is a very important aspect of the project itself. So we need to bring them in order to help the autonomy itself, improve the AI itself and the machine learning, and the AI and trust. This is the last one, but it's the most important one. The most important one. Without the trust between the whole stakeholders, not only like the pilots themselves, because they are like the users of our technology, we need also to build the trust within the other groups, such as the managers, such as the developers, and also, of course, you know, the end users, like you know, like the customers of the service. So very quickly about the SESAR Darwin project. The project started 1 year back in 2023. It is going to last to 2026. And one of the objectives, or one of the main objectives, is to demonstrate the capabilities of this project on a single pilot operation precruiser. To be more specific, we are speaking about Pipistrel, which is part of the consortium, and we have different technologies to develop with the ultimate aim to bring technologies that will serve the extended minimum crew operation and the single pilot operation. Here we are speaking about digital co-piloting and pilot assisting, pilot state monitoring, and human-machine teaming with trustworthy machine reasoning engine that will be on the level of EASA 2A at 2B, hopefully. We are approaching this in an agile and iterative development, again, as I said, with our partner Pipistrel, to bring an SPO solutions for Part 23, but we also we are aiming to align it with Part 25. Of course, not myself, but my colleagues are working closely with EASA toward the certification path, attending different working groups in this term. So very quickly, why do we need an AI in cockpit? Yeah, of course, we all know that we need AI in cockpit, and this is the actually reason of having this forum. So if we speak about the current modalities from the Honeywell perspective, we have new interaction modalities, for example, we are interested in, such as the voice control, the touch, and for example, the face recognition to adapt, the cockpit to the specific pilot, for example. This is something we are working on currently. Most of the work we are doing now at Honeywell is actually based on rule-based system with the reasoning. But of course, we are thinking also about, bringing machine learning, AI technologies on portable electronic devices to help the pilot with the operations. If we move on, this is the current situation. If we move on, in the span of 5 years, probably, we are speaking about the simplified cockpit operations, which is aligned with the extended minimum crew operations. We are in a need for the pilot state monitoring technology, so to actually detect the dangerous state of the pilot, for example, and also to assist the pilots in the case that there is abnormal situation. We can also speak about the ATC compliance monitoring. This is one of the possible applications for the EMCO. And of course, all of these will require the certifiable machine learning and reasoning platforms. For the future, in the span of, let's say, 10 years, we are speaking about the more autonomous operations like the SPO. We will definitely need intelligent assistance and human-machine teaming in order to enable this kind of operation. So in terms of the project itself, we have 3 main objectives. The first one is actually the human-AI collaboration, which actually aims at dynamically distributed tasks based on pilot. I would not use the word health. Sorry for that. It's the psychophysiological state of the pilot and the current and upcoming task load prediction. And also to provide the collaborative capabilities for the pilot interaction with adaptable automation and assistance, and ensure that the pilot stays in the loop. That is a very important thing. We want to ensure that the pilot stays in the loop and in charge even in demanding situations. So basically, the pilot will have the final word about what the system will do. The second aim is actually to create or to design the monitors. Under Darwin, we have 2 monitors. We are speaking about the pilot state and the task load monitor, with the aim to monitor the condition of the pilot. Again, as I said, we are speaking about what is called the psychophysiological state of the pilot, like the drowsiness, sleep, incapacitation, and also to predict the possible increase in the workload during the planned flight route. And the third very important technical enabler is basically the trustworthy machine reasoning platform, which will provide the capabilities for rule-based, transparent, and explainable decision support for the decision-making. So within Honeywell, I will speak little bit far from the project itself, but within Honeywell, we were working in the past years on in terms from the perspective of the crew resource management, we were working on the monitoring, so to monitor the state of the pilot. So we are, as you can see from this slide, we are covering just one portion of the crew resource management. And based on EASA concept paper, we are working on level 1, probably level 1B. I would love to discuss this with the corresponding people. And within Darwin, we want to cover more aspects of the crew resource management. So it's not only the monitoring, but also the cross-checking, the decision-making, situational awareness, and the support of the communication. So yeah, so now I will speak in more details about one of the technical enablers of the Darwin project, which is the pilot state monitoring. And since we started with it, even before, you know, like we started working within the SESAR framework. It is basically the most matured one of the technologies or the enablers we are working on. So what we are aiming at is to develop unobtrusive pilot acceptable technology for the detection and long or short-term monitoring of states that cause partial or full incapacitation. And obviously, like even like out of the scope of Darwin, this is we consider it as a very key enabler to extended minimum crew operation, EMCO, and of course to the single pilot operations, the SIPO. And what we were working on in the last 5 years, it was on the detection of sleep and drowsiness. So we are trying to prevent the sleep. So notifying the pilot if he or she is going into a dangerous state in terms of the vigilance, even before something bad happens, right? So yeah, in terms of the technology we are using, we actually worked with different sensors, but with the most mature one is actually based on a single camera integrated in the cockpit, and we are using the visual information. Of course, we have some parallel solutions that we were working on based on some wearables, for example, some sensors that are integrated into the seat, for as an example. Yeah. So yeah. So what we are bringing into the Darwin in terms of the pilot state monitoring is basically the detection of incapacitation. This is also a very long story. I would love to have you on my stand to discuss this later. But what we are targeting is actually the obvious incapacitation, which means that we don't actually care about what is the causing of the incapacitation, but we want to make sure that our accuracy in terms of the detection is correct. So we are actually not detecting the partial incapacitation caused, for example, by gastro problems, but the obvious one caused by loss of consciousness, sleep, death. Hopefully not. Yeah. So as I said, I would love to have you on my stand to speak more about the technical details of the solution, especially the pilot state monitoring, but in general about Darwin project. So please join me there. And my last slide is about basically the variability of data. So there were many discussions yesterday about, you know, like the generalization in terms of the machine learning and other things. But what we found out, like based off our experience, is it's very good actually to split the variability, the causes of the variability, depending on their sources. So for example, from the pilot state monitoring perspective, we are speaking about 3 sources of the variability. The human being variability in terms of gender, age, ethnicity, of course, including skin color. That is significant, of course, but it's not aviation specific. So we need to take this in mind. When we go one step further and speak about like the state itself we are trying to detect, whether it's sleep, drowsiness, incapacitation, then the variability is very small. Like speaking about the specific states we are talking about, like the sleep, most of the people will have closed eyes, for example. They will not move, etc. So from the machine learning perspective, it's very important to understand that the state we are going to detect depends on its characteristics from the psychophysiological point of view. So here we are speaking about low variability, about from the aviation perspective, we are speaking about a generic state. So it has nothing to do with the aviation itself, of course. The third variability that comes into the game is basically the aircraft conditions, of course. So the camera location, the lighting conditions, the dynamics of the aircraft, you know, like the vibrations, for example. Of course, here we have a significant variability. If you are speaking about a smaller aircraft, it's not the same about like speaking about a large passenger aircraft. That's obvious. So we had to tackle all of these variabilities during our research and development. And yeah, that's all, I guess. Thanks a lot.
Thank you very much, Hisham. So now we will move more to the viewpoints of the airlines with what is happening in Lufthansa with Nima Barachi. The floor is yours.
Thank you so much. Good morning, everybody. Thanks for having me here. I'm Nima Barachi with the Lufthansa Group, and I'm very happy to give you today a short overview on what we do with AI in our production. So where do we come from when it comes to AI, where we currently are, and also where we are going to go to. Awesome. First of all, a quick overview on where we currently are at Lufthansa Group. So in March, our 2023 figures have been released, and right now we know that in 2023 we again connected more than 123 million people. We connected them using, on the average, 3.6 liters of kerosene per 100 kilometers per passenger, and we strive to do more. We try to achieve this goal of reducing our environmental impact by increasing the intermodality of our offering, but we're also applying new technologies like machine learning, like artificial intelligence, to further reduce our fuel consumption. Just to give you an example, with our OPS-D project in 2020, we managed to save more than 7,000 tons of kerosene just by assigning the right aircraft to the right rotation. Before we can really dive into where we as Lufthansa Group are going to be and what we are doing currently and where we were with machine learning and artificial intelligence, let us have a very quick and brief look on where the machine is actually coming from, where the machine currently is, and maybe also where the machine is going to go to. So if we go 70, 80 years back in time, in the 50s, we established AI, and AI was focusing on symbolic logic. From 60 to 80, from the 60s to the 80s, this was like the rise of the statistical approaches. Bayesian networks have been used, and everybody was about, okay, we now look at distributions, we have to look at connections between and identify dependencies, and this is where really the big age of statistics was rising. In the 80s, machine learning emerged, neural networks, and the term artificial intelligence got coined more and more. Everybody said, well, one day if a machine has managed to beat man in chess, this is going to be artificial intelligence. In the 90s, IBM managed to beat a man in chess, Deep Blue, and it simply became machine learning again. In the 2000s, with the data storages, with computational power, both increasing, the deep learning approaches emerged, and more and more the machine could do more and more. The machine could operate on more data, could digest the data quicker. And then the 2010s and the 2020s, as we all know, this is the age of general AI, and what is going to come next. Well, if any one of you has followed the Game of Thrones around Sam Atwell and around OpenAI, everybody's now thinking that the next thing is going to be the artificial general intelligence. Whether this is going to come, I don't know, but I'm about one thing pretty sure. Once we achieved it, it's going to be machine learning again. Now, let's take a look at us, at Lufthansa Group. So where do we come from when it comes to AI, where we are and where are we going to go to? And let me start in the year 2014. So not very long ago, 10 years approximately. In the year 2014, we had a challenge within Lufthansa Technik, and more specifically, the repair order management. Everybody who knows a little bit about engines knows that you usually look up in a database for the damage that you're currently looking at. You're looking at the database whether you found something similar, whether there was a similar damage in the past, so you can assess the price, the duration, and the magnitude of the repair. At Lufthansa Technik, we were, and we currently still are, so I had a phone call with him last week in the very privileged situation that we have Klaus Dau. Klaus Dau is the walking database. Every employee always approached him and asked him, hey, Klaus, I have here a damage on my engine. Do you recall a similar damage somewhere? And Klaus said, yeah, I recalled that. And Klaus just answered and said, okay, this is the damage, look it up. Everything was good. But everybody was also aware that Klaus Dau is going to retire one day. So what did Lufthansa Technik do? They fed all the information in the picture database, combined with what Klaus Dau always said, into a machine learning model, and said, okay, we are now employing reverse image search. We're just putting the new picture on top, asking the algorithm whether this damage or similar damage has been assessed previously. And then finally, the machine gave the answer, yes, there was a damage. This was the estimated repair cost. This was the estimated repair time. And we are saving right now 2,000 hours per year, and we call the tool iClaus in honor of Klaus Dau. Currently, we're also doing a few things with machine learning, and we need to only go back a few years again. 2018, we started at Lufthansa Technik the AI-driven maintenance program. And I'm not telling you anything new. So everybody who knows the Boeing product, the Airbus product, knows maintenance optimization, predictive maintenance is a product which is out there, which is being used by people and which is being used by airlines. So we at Lufthansa Technik, we also said, okay, we are trying to move more and more scheduled maintenance to on-condition maintenance to predictive maintenance. We try to assess in which state is the aircraft going to be, is the component going to be, depending on the usage history. For this, we started to make all the findings that we made at Lufthansa Technik, we started to structure them. So you can't do a lot of things with greasy. So for the one mechanic, greasy means one thing, for the other, it means something different. But if you collect all the greasiness and take pictures and also correlate this to the actual repairs, you get a pretty good idea on what greasy really means. And then you can assess that after a while, a component which is greasy may require so and so many hours of repair. We looked at the usage. We're currently still looking at the usage. We're taking operational data, feeding that into the model as well, train the model. And by this, we move more and more items from scheduled maintenance to prescriptive or predictive maintenance. Our next steps, of course, as always in our wonderful business, we try to get access to more data and also to include our engineering know-how, so to train the machine better. So we are moving to a human, from a human in the loop, also to a human over the loop approach, where the human being is observing what the machine is doing and providing the machine with feedback whether something was correct or not. This is a small part which feeds into the overall operations layer that we are also developing at Lufthansa Group. Since 2019 now, with our colleagues from Google, we are integrating the different assets that we have data-wise and get them into a holistic optimization approach. So we, as Lufthansa Group, if you go for operations, you of course have on the one hand side the operations control management, but one of our most important and also most, I wouldn't say expensive, but let's say precious assets, the crews, are also being managed. With the crew management, you have to adhere to tariffs, you have to adhere to duty regulations. So these are aspects which go there into the optimization. You look at the passenger. In case of disruption, you can't just have them sitting there at their airport. You want to bring them on time to the destination. So we're also optimizing that. And here, technical fleet management, which is also being supported by IATA from Lufthansa Technik, is a further layer. So these are layers that we bring into the OpsD cloud layer and achieve a holistic optimization but still step by step. So starting in 2019 with a short interruption due to the Corona crisis from 2020 to 2021, where we had to ramp down the project, we are now focusing on having the tail solver, the passenger solver, and the crew solver operational by May 24. So basically by next month. So what are these solvers doing? The tail solver looks at the most efficient aircraft. The passenger solver looks at the most suitable alternative for our passengers to get from A to B, and the crew solver tries to optimize the roster. Every of these solvers, right now, we do have dedicated tools optimizing each one of them. But in the future, we want to do this in an overall irregularity solver, where we say, okay, under these conditions, the optimal solution, and this is again where we employ AI, machine learning, this is going to be the best solution. Then bring techniques, Lufthansa Technik, bring tech ops into the game, looking at the maintenance solver to then also implement the ground solver in the future is also one of our goals. So I gave you an idea on where we come from, on where we currently are, and now let's take a quick look at where we are going to go to. This is a project that we did together with our colleagues from Lufthansa Aviation Training. So everyone who's familiar with the foredeck process knows that in case of a disruption on the flight deck, in case of an emergency on the flight deck, pilots go through a structured process by identifying, first of all, the fact, looking at the different options, evaluating the risk and benefits. Then they decide, execute, and check whether the chosen path has led to the desired results. What we ask ourselves is, when we know all Gen AI is a very, very talkative instance, it's a good talker. What we ask ourselves is, what if we would feed the operating manuals A and B into a Gen AI tenant? What if we would connect that to a chatbot? What if we would also connect that to the Lido database of all the airports that we have, to the state information of the aircraft, and also to the company internal database of findings of pilot reports? Could this approach in any way help us on the flight deck to find a decision quicker, to go through the foredeck process more quickly? And this is basically what we did. So we fed all the data, all the information into the Gen AI tenant, connected it behind a chatbot, and then implemented it on an iPhone. And the result was the foredeck AI augmentation system. This system allows the pilot to go through a structured question and answer process. And by this question and answer process, the pilot can identify the most suitable alternative airport for the current situation. So we simulated it through with a situation where an aircraft was in the vicinity of Athens over the Greek islands. We had an electric failure. The machine went through the Q&A with the pilot, asked the pilot about informed the pilot about the different options, and we assessed that the usual process, which currently takes roughly about 35 to 40 minutes, was cut down to 5 minutes. So why did we do that? Not because we really want to have Gen AI on the flight deck, but we would like to have an opinion on whether the use of artificial intelligence makes sense on the flight deck or not. Also under the current development of the EASA AI regulation, I think this is one of the important duties that we as Lufthansa Group have. We again want to ensure the safe and efficient transportation of our passengers and crews, and this is why we investigated this. Next steps for us in this realm are to fine-tune the machine and also to go for, so we had desk trials right now to potentially also go for some simulator evaluations, just to see also how the feedback from our pilot community is, whether they would appreciate such kind of support or not. Again, I only said, well, this is maybe what we are doing. We have no idea what really the possibilities that come with the use of AI, how this is going to develop within the next couple of years. But right now, we see that it's going to have a huge impact on our operations, not only the strategic planning, but also on the tactical planning, and maybe one day also on the actual execution of the flight. With this, I thank you very much for your attention and look forward to your questions later on.
Thank you very much, Isham. Sorry, Nima. And now we will. I think there will be some links in the next presentation, which is coming from colleagues from Sun Express and also Istanbul Technology University. So I will call now, starting with Doyan and Emre. If you can come, the floor is yours.
Hello, everyone. This is Doğan from Sun Express. Today, Emre from Istanbul Technical University will be with me. We are collaborating with Istanbul Technical University on Operation Shift Assistance AI module. Yeah. Today, basically, I will explain what is the exact meaning of Shift Assistant and what is the AirMind module of it. And also we'll try to brief overview to areas where we can use AirMind. And then Emre will explain structure of the LLM. Sorry. LLM and AI agents, and will provide some technical details on it. So as you already know, the operational complexity and number of aircraft and flights and flight traffic increasing. So for that reason, as Sun Express Airlines, we decided to find a smart and intelligent way to manage our operation, and decided to consider every operational data into the one system to manage our operation in efficient way. For that reason, for instance, if I give you an example, in IOCC we have 15 to 20 different screen needs to be checked by the shift guys who is working on the daily shifts. So if we can take all the operational data in one system, it's a kind of single source platform, then we can manage, monitor, and track our operation in efficient way. But it doesn't end there. Of course, we need some smart solution and additions on it. So for that reason, we started to develop an AirMind module with Istanbul Technical University, and we've currently focused on 4 different modules of this improvement. The first one is the query mode, where you can ask some operational questions and get results in seconds. It's basically something efficiency based, and also it's the phase we almost completed, that I can say. And the second phase is the data enrichment phase. It's basically capturing the text-based data into the system, and also documents as well. So if we can convert all those information into the data, then we can have much more data-driven insight. And the execution mode, I think this is the fancy part of, or cool part of this project, that I can say is, you know, there is other technologies that we can use, such as RPA, robotic process automation. So if we can combine LLM with RPA, then maybe we can assign a task to AirMind, and maybe we can take advantage of this and reporting and analysis phase. This is the latest one we focusing. By saying reporting and analysis, as an analyst, sometimes it really takes time to create a report or analysis. But if we can inject every operational data in a single platform, in that way, we can just ask simple questions and get back in data-driven insights, such as, hey, what was the problem at Frankfurt Airport in 2023 related with, let's say, baggage search? And bam, you can see you can take the response, get the response, and maybe you can see light at the end of the tunnel. So this is my part in our presentation. Try to explain why do we need a kind of a solution. Now Emre will continue with the technical details, and thanks for having me. Emre, stage on yours.
Thank you, Doğan. So, hello everyone. This is Dr. Emre Koyuncu from Istanbul Technical University. So, this is okay, great. So, when we come to collaboration with Sun Express Airlines, actually, we sit and talk about that the potential solution and also understand the environment of the airline. So we saw that there are a lot of tags. Also, there are a lot of emails coming in and out. So, and there are many documents. Also, there is a speech. Speech is also a big resource there because dispatcher is talking a lot. So giving us some information about the structure of the operation. So we saw it. Then we understand that we should have the contextual understanding behind of this solution. And also we need to provide the alerting, decision support, etc. So when you solve such things, actually, it goes to LLM, right? So this is simple solution. This is new boy, actually. It comes to LLM side, large language model. But also we saw that we need to go for the automated process calls. So we need to call somehow to, to do the analysis. Also, somehow you need to calculate the delays. You need to calculate the some fuel. So you need to go for the new flight plan generation, etc. So we saw that we should go through this way. Also, there are multimodal connection because there are many stations that you need to work together. So also you need to provide the coordination. When you have the such thing, actually, we are talking about the multi-agent system here. It should go through the, consider the overall performance. It is not only considering the single agent performance. You need to go for the overall. You need to go for the adaptivity. So when it comes to through this way, actually, we are talking about the agent, AI agents. So this is why we call them as the LLM as AI agent. So this is actually the summary, what we are doing behind of this AirMind. So this is quite pretty much good summary, but of course there are many details. But when you see this picture, actually, we have a lot of interfaces working with the data and the operator side as well. So when it comes to operator interface, of course, when we talk about the LLM, we have some data mostly coming from comes as the text. So actually there is a speech as well. So you can go through the text. You may have the the speech to text system. So then you can understand what's happening. So if you had the chance to see the our demo in Airspace World, actually, we tried to show that we can understand the context while dispatchers are talking. Actually, the demo was related with the diversion management. This is quite complex operation, actually. So there are a lot of things going on. So when you have the diversion, you need to check that. You need to check the weather. You need to check the other airports. You need to check the fuel. You need to check the transfer passengers. You need to coordinate with the other departments like, the transportation. In airline side, they are doing pretty much good job there. So as a human. So we thought that there need the support there. So this is why we put the AI. So when we come back, actually, in this case, we try to, to put the other coordination with the chat box. And to understand, this some information that they are consuming on the operational side. So they have a lot of databases here. So they are working with the many databases, passenger databases, flight plans, net lines, other things. So in this case, actually, you need to consider all the things together. When back to my PhD, actually, I was working with the EUROCONTROL data a lot. So DDR2 database. I was using all of T+, etc. So I would know all the part of the data. So I have the huge information about it. But now we are consuming a lot of database. I guess for the specific example, we have more than 20 databases. I have no idea what it's saying, actually.
we have some dictionaries for the data, and we are just, the training LLM as an agent. So they are consuming all the information with the prompts that you are giving. Actually, it gives the results. So this is also promoting the adaptability. So when you have such new data, actually, when you introduce the new data, you provide the dictionary, and you can give the, additional information. Also, this is a structure. We are not using a single large language model here from end to end, actually. So we have the different kind of LLMs working together to somehow is handling the databases, other one handling the prompts, etc. So somehow we are concentrating all the things together to get the good results, also preventing the hallucination and other problems. So this is some examples I would like to give from the practical side. So this is kind of, the examples from the flight diversion. You can just ask, some questions like, how much alternate fuel for this flight. So you can get the answer from the database. Also, you can ask the other questions, what is the transfer passenger count here? You can get the answer. This is simple chat box that you can get the answers, that you can consume all the database coming from the operational side. This is another example as well. In the diversion management, actually, you need to consider all the, the minutes that you can ask that, how many infant within this flight, how many passenger that needs help. So you can get the answer as well. So this is also, you can ask that, how many flights comes to Bodrum. So you can get the answer. And then you can use some math here, because LLM agent can handle it, actually. For example, you can ask that, what is the total delay for this flight? So you can get this one, actually. You can ask the, the specific delay code as well. So I will explain this one later in a minute, actually. So also you can ask that, what is the average delay for this, the Izmir flights? So you can get this answer as well. So this is simple mathematics, actually. You can run it. We are not specifically running a process here, but we can do the some calculations. When it comes to, the flight log checks, you can do the things as well. For example, you can ask that what is the reason of the delay for this flight? So you can get the answer that, because you have this information within your database, saying that for this specific flight, you have this delay code and lasted total 30 minutes. So actually, this is the extra information. It's the LLM agent thinks that this is kind of related with this, so given an extra information. But it's just saying that the delay code is 15. So even now, I don't know what it means. So when you want to, introduce the new information, actually, you can give another database, and you can give a dictionary. What is those IATA delay codes, actually? Then you can get the more improved answer. So you can ask that how much delay due to the runway restriction. So this guy knows that the runway restriction is 8-9. Then you can get the answer. So this is how you can provide the the scalability. So what we are going to actually, would you like to to put all the LLM agents together and concentrate all the things together, and want to give that those LLM agents are talking at the different modes. So you don't have to communicate in a the unique way. Actually, they are just the sharing the information. You don't need to create new message types. You don't need to talk about the some kind of the standards, etc. Those LLMs can talk together. So we are thinking about that as a future work. So that's all from my side. Please come to our stand and check our chat box. Still, we are running with the baby steps, but we are running quite fast. So please come to our stand and let's meet there. Thank you.
Thank you. Thank you very much, Emre and Doyan. Now we move to the last talk, and it will be about mostly the aspect of the environmental sustainability and how AI can help us to detect contrails and to potentially avoid them in some ways, at least to better understand them and to maybe improve our operation in the future, avoiding them. So my pleasure to call on stage Gabriel Jarry and Junsi Sun.
Good morning, everyone. My name is Gabriel Jarry. I'm data scientist in the aviation sustainability unit of EUROCONTROL. And today, together with John Jason, which is assistant professor at TU Delft, we'll give you an overview of our research activity around contrail detection and modeling using deep learning. So, as you may know, contrails are more and more analyzed due to their potential impact and contribution to global warming. It has been shown in particular by David Lee that the effective radiative forcing of contrails and non-CO2 emission could be of the same order of magnitude as CO2 emissions. This takes two elements. Basically, what we know is that contrails are usually cooling during the day because they reflect the light from the sun, and has an important warming effect during night because they trap the infrared radiations in the atmosphere. If we go deeper into the contrails formation and physical properties, we know that contrails are clouds that are formed from exhausted aerosol particles from engines, and this is a two-step process. So the first step is that these particles activate into water droplets, and afterwards I think there is something here. And the particle afterwards freeze into ice crystals that grows and remains in the atmosphere under certain condition of temperature and pressure. If we now look at it using a thermodynamic perspective, it is usually represented as an isobaric mixing from the engine temperature and pressure through the ambient pressure and temperature. The formation of the contrail appears when this isobaric mixing crosses the water saturation curve, which is the upper one on the right graphs, and the contrail persists if the final condition, meaning the temperature and pressure, stays above the ice saturation curve, which is the lowest one. If this temperature and pressure are below this ice saturation curve, then the contrail disappears. So this physical phenomenon has been studied for decades, and it already exists several tools in order to model and follow the persistence of the contrails. And these models highly depend on their inputs, which are basically the aircraft performance model, the aircraft trajectory we use for these performance models, and the weather data we use to model it. It has been shown recently that this prediction task, in particular for the persistence of the contrails, is limited by the accuracy of weather prediction, and in particular relative humidity. In this context, current research community is looking into alternative, and in particular the use of artificial intelligence and deep learning methods in order to consolidate, validate, or even enhance this modelization using remote sensors. When we are talking about remote sensor, we are here talking about geostationary satellites, low orbit satellites, or even ground camera and LiDARs. At EUROCONTROL, we are using both satellites, and we have also bought some ground cameras that are located at the innovation hub of EUROCONTROL, and that are both looking into the visible and the infrared domain. If we now look a bit about the deep learning segmentation task, basically the objective is to delineate and identify contrail on images that could be both satellite imagery or even ground-based camera images. To do so, we usually need extensive label dataset, which are costly to create. And for the moment, it will exist only few datasets to build those models. And the major one was published by Google last year, and it accounts for around 20,000 images for the US geostationary satellites. If we now look at the modelization and the neural network that are used to segment contrail on images, the best models for the moment are the UNet architectures, which are a particular U shape which is based on the architecture, which is an encoder-decoder architectures. So the encoder is used in order to extract some high-level features from the image. So it reduces the dimensions and extract high-level features. And the decoder part is made to recreate the mask and detect the contrails. And it has a particularity of what we call U-shape, which are the arrows you can see in the image that transmit information from the encoder to the decoder. What makes this architecture particularly efficient is that they uses, for the encoder part, existing classification backbones. That is to say that they are using the weight of already existing models that were trained, for example, on ImageNet dataset, and that are already trained in order to detect some pattern in the images. For the task of detecting contrails in imagery, it has been shown that the best model for the moment are not classical convolutional network, but neural network using vision transformer backbones. So here are the results of what we can obtain using this type of model. So basically we have images and the models are able to detect and select or give the information on what pixel, where the contrails were located in the images. And for the moment, the best model we can create on those datasets, for example, the dataset given by Google, is a score of 72% of DICE score, which is a pixel-wise correlation score. As a complementary information, at EUROCONTROL, we have performed some hyperparameter analysis, and we have also highlighted that using combined loss and using average label from different labelers usually improve the performance of the models. And we have launched last year the ContrailNet initiative, which aims at helping research community to validate and improve their models through a common repository of contrail observation data and label data. We have started this year a labeling campaign on our ground cameras, and we are waiting for the European geostationary satellite to provide also a dataset on satellite imagery. And EUROCONTROL will share this dataset to help the community enhance their models and validate their models around data contrail science. So what are the future steps at EUROCONTROL? Basically, we will use this model in order to build some pipeline for the monitoring and tracking of contrail on both our ground cameras and the European geostationary satellites. We will use this prediction in order to build and enhance the current prediction of ice supersaturated regions. And we want also to research regarding the modeling and the contrail formation and persistence using our ground camera with an hybrid approach. So just before leaving the floor to Jonji for the second part of this presentation, I wanted to say that with my colleague Philippe Very here, we have a booth and you can come and see us during the breaks. Thank you.
Thank you, Gabriel, very much for sharing the stage with me and also give the very important background about this contrail detection. Let's start. So I'm Junji San from TU Delft. I work with air traffic management. AI is one of the kind of research topic that I deal with in many of the research we have done in TU Delft. So continuing what happens in the previous part of the presentation, I will explain a little bit of a new development called few-shot learning. So we really try to build models with only a few images. And I want to explain how to detect the attitude of the contrails, so shadow detection. So few-shot transfer learning starts again with this UNet network structure. I always find it very hard to explain, the encoder-decoder network. But if you have a kid or multiple kids, it is very easy to explain because the kids are perfect example of encoder-decoders. Before age of 5, they're basing work in the encoder mode, right? So they learn things, they look at picture, this is a dog, this is a cat, this is an airplane, that is train, this is air traffic controller, that's pilot, this is a Pokemon, different type of Pokemon. And they listen to you, right? To give input. But from age of 5, they become a decoder. They start working in the decoder mode. So they not only know what things, hundreds of Pokemon, but they can start to draw, Pokemons. So that's the kind of generative part of a decoder network. So in this case, you can think that this network as a young child, he learn things and he abstract this in a latent space and then generate things. Very similar to what we do with Contrail. So in terms of pre-trained, models, it's basically when they grow older, let's say 18-year-old, they move out of the house, they have to paint their own house, right? They don't need to learn how to make a stroke anymore because they already know how to paint Pokemon, for example. So they only have to watch maybe 2 YouTube videos, and then they start doing all the painting job. So this is kind of like using a pre-trained model to reduce the time of learning. And in terms of future transfer learning for the contrail detection, what we do is that we basically accurately label about 30 images. And we apply this kind of model on the pre-trained networks. And we will be able to reach already a very high accuracy compared to the models that trained from start. So what we had is that with only about 30 images, we were able to reach a very high level of the accuracy by validating the model on the Google Contrail. In this figure, what you can see on the x-axis is the number of contrail pixels. On the y-axis is how accurate they are. The higher, the better, right? So the lower part of on the left part of the region is really image with very few contrails in the image. On the right-hand side, you see like the image with a lot of contrails. The increase of the accuracy with a lot of contrails being labeled being present in the images. And we did a campaign try to reduce the number of training images using the Google dataset. So you can find that with number of 400 images from the Google dataset, you can already reach a very high performance compared to the training with thousands or use all of the images from the dataset. So this is the kind of test we can prove that we don't need, maybe we don't need a lot of images. We just need some very accurately labeled image with a smaller dataset. Last year, when we're looking at some satellite images, especially for the Landsat, we noticed this image, and is a contrail with its shadow casted on the ground. And this is a perfect point for us to understand how high the contrail can be, because knowing how high the contrail, you can correlate with meteorology information, then you can really build models that accurately describe and estimate, kind of attitude of aircraft, attitude of the contrail. So this is a diagram, shows you how you can do the calculation if you know the sound angle. And so basically on the right-hand side, you see that we have the training and labeling for the contrail. On the left-hand side, you see the, the other way. Left-hand side, you see the for the contrail. On the right-hand side, you see the labeling for the shadows. So we throw them in the same unit. We can have a very good prediction of contrail, as we already seen. But for the shadow part, it's a bit more complicated. Then we thought about how about we use both of the channel and trying to predict the shadows. And in that case, we were able to actually quite accurately predict the shadows based on the input of the Landsat image. So this is kind of process that we have seen so far. You can see on the right-hand side, in the fourth column, those are the shadows, and some of the ground features, like even though they are dark features, they're not identified as shadow anymore. So with this combination of the models detecting the contrail and detecting the shadow, we are able to estimate the height of the attitude. So what we're trying to really work on is that to make this code open access. In the end, you can run very simple script training your own model, and you can bring your own data, use the same kind of network architecture to train. And what happens is that in the future, we really want to make this model more accurate. For example, using the data from ControlNet initiative, and try to create a new curated data set, and really try to improve the shadow detection so that our algorithm works very well. With that, I would like to thank you very much for the presentation. Into that, we also work on a lot of other topics like AI for trajectory generation, for delays, and also for voice recognition. So I'll be happy to discuss with you after talk, and maybe with child education. Thank you very much.
So thank you very much for this really impressive panel on quality of the presentation. So I have a lot of questions on my side, but I expect I'm not going to use them because I think we should get interesting questions from this audience. So don't be shy. We're waiting for questions from you. And we have something like 15 minutes for that, which is really great. Thank you all, the panelists for and the speakers for maintaining their time. So we have this question and answer. So who's gonna be the first to raise question? Okay,
Hi, I actually have a couple of questions. First, for the Hellenic drones presentation, I was wondering from the challenges list, how are you dealing with the weight and processing power that you're going to need for 8 cameras being processed on a drone?
Yes, thank you. This is obviously a challenge. The concept that I described is the fact that we can accommodate up to 8 cameras, and not all of them will be processed simultaneously. So depending on the architecture that the user will prioritize, they will select which cameras will be active at each time. I mean, they could be processed in series, so not all of them will be processed at the same time. So that's what we do so far.
Thank you. And if I may, the second one was for the Lufthansa presentation regarding the foredeck. I couldn't really understand if you already have conclusions of the usage experience of that system, but I was wondering from my own side, wouldn't it be easier to simply introduce a rule-based electronic checklist based on the sensors and what we've defined on the operator's manual and the checklist versus the risk of hallucination from a large language model?
Yeah, so first of all, thank you for the question regarding the first part. The first question was on, sorry, I will answer the second part and you have to ask it first again. So the second part of the question, whether it would make more sense to use electronic checklists. So we deliberately used Gen AI also to investigate the case of hallucinations. So we want to have an opinion, a well-founded opinion on the use of AI on the flight deck, and this is why we deliberately chose this approach rather than an electronic checklist. And now the first one, sorry.
It was more about understanding if you've already had findings from the users of their usage of that system.
So right now, the first finding was simply that it can accelerate the decision finding process on the flight deck, since we compared it to the current timing when the flight deck crew has to go through the checklists manually and also get hold of the sensor data. What makes life, of course, easier is when the sensor data is connected to the system, so that, as you said, electronic checklists can pre-populate already. But apart from that, again, it was only a test in order to see what are the limitations and the possibilities. So no findings that would even have any impact on our operations have been found in the project.
One here.
Well, first of all, thank you all for your presentations. Very interesting. My question is for Mr. Attassi from Honeywell. In the scenario of reduced crew operations, have you considered in the scope of the project what the tool is going to do in case of a full incapacitation and there is no one capable of actually flying the aircraft?
Yeah, absolutely. So as I mentioned, like the project started 1 year back, so we were like preparing like the technical background of the project itself, the specific use cases and the scenarios are coming now, basically. And I find myself, to be honest, I'm not the principal investigator of that project, but myself, I find very interesting to take the incapacitation, the complete incapacitation for Part 23 as a very interesting use case that can actually be part of the Darwin project. So once the incapacitation is detected during the single pilot operations, especially within the part of 23, that we can use Darwin, for example, to inform the ground that the pilot is incapacitated, trigger some mitigation strategies like autoland, for example. So yeah, absolutely, we have this in mind. Yes. As I said, like we are just finalizing the shape of the use cases / scenarios we have within the project. But very interesting question. Yeah, we have it in mind. Thanks.
Thank you. My questions is a continuation of the previous one. What problem are we trying to solve with the single pilot operation to start with? And second, if I understood correctly from several presentations there, we have the ability to teach the algorithm to act proactively like the humans in the flight deck are doing. Do we have this ability to train the algorithm to act this way? Thank you.
Yeah, so not really. To be honest, the aim of the Darwin is to make a generic platform that is able to support, like the SPO operations. So it's not about like, yeah, of course, like the ultimate aim to have a digital co-pilot, what we call the digital co-pilot. But this is not the aim of the Darwin project. It's more about to have a digital assistant of level 2 from the EASA perspective that will support the single pilot operations, especially for part 23. So meaning that we will not replace the pilot. We won't just help him with distributing the tasks between the assistants, what we call the assistants, and the assistant might be, for example, an ATC communicator. So you would say, okay, as a pilot, you have plenty of work. You won't just, like to actually delegate the ATC readback to a certain digital assistant. So what we are trying is to make the generic platform, right? Not replacing the other pilot or not replacing the pilot, him or herself, right? I hope I got your question and I replied to it. Yeah.
Hi, good morning. Thanks for the presentations. This is Sergi from Crida. And for the last presentation where we have seen, we have been taught that data is always the power of machine learning. And we have seen a couple of slides where it seems that having fewer data is better than a lot of observations. And I was wondering if you could give us a little bit more details about how you downsample or how you have selected this smaller subset in order to do these transfers. Thanks.
Thank you very much for the question. In fact, we are not trying to say that less data is better than more data, because if you have accurate, more data is always better. But in reality, you don't always get that, right? So what we're trying to prove that for a simple task like contrail label segmentation, maybe it can be done with less data, right? And so what we try to rely on this kind of small data set is that we want to make sure that this data set is representative in a way where you have a different background, right? So the neural network will be able to learn this. But of course, there are other techniques like image augmentation. So you can apply heavy image augmentation to achieve different contrasts, different backgrounds, different perspective. So in this case, we are trying to overcome the limitation of lack of data to build models with this small amount of data set. If you able to have a large data set, let's say with 20,000 labeled images, then it's always good to use that. The training might be slow, but then you have a more accurate model. Yeah. I hope that answered your question.
Maybe here.
Okay, Gabriella from Cira. I just want to ask, I heard these different terms like digital assistant, digital agent, digital copilot, and yesterday digital assistant again, digital controller. So I was wondering, because it's my interest, what we think about digital assistant, which is our imagine, different application on the flight deck that interact with the human, just one digital assistant just as a whole, which is our thinking of digital assistant.
Yeah. So to be honest, this is not like standardized, right? Like terminology. like the digital co-pilot, like every company or university might, like feel it on their way. So basically, like from our perspective as Honeywell, like this is just my feeling. I'm not speaking about all of my colleagues, but this is like probably the ultimate third level or fourth level in terms of EASA. Like, like almost autonomous, or actually, like something like AI technology that can behave as the pilot. But again, I should stress out that from our perspective, what we are doing on Darwin, it's not about replacing the pilot, it's about helping him, right? So I would not like bother myself, to be honest, thinking about what is the digital assistant, because it's very broad word, right? Even though like the digital co-pilot. So everybody can understand it in a different way. Just my gut feeling, like the digital co-pilot is something like very high autonomous, maybe level 3 or level 4 in the future from the in terms of EASA or SESAR, even from SESAR perspective. So yeah, so from our point of view, we are speaking about digital assistants. We are not speaking about digital pilots. We are working towards the digital co-pilot. But now we are claiming that we are working on digital assistants. So not replacing anybody, just, helping during abnormal situations, during high workload, the pilot to do his or her duty. That's all.
Yes, there was a question there, and then maybe one more after.
Alessandro Priester, SESAR GU. No, just maybe just one additional information to complement Honeywell presentation. So our vision is first to go to the minimum crew operations. That means that before going to the single pilot operations. Minimum crew operations means that there is still a second pilot on the plane, which would be maybe resting while the other pilot is flying the plane. Okay, typically during an Atlantic route. And in case of incapacitation, then this pilot can be called automatically by the system and is able to go into the cockpit. And the single pilot operations is a more long-term vision, and in case it would be really a need because of limited number of pilots that would be available for flying a very large number of fleets. And that would require a very advanced AI, and of course has to be very sophisticated and allowing aircraft to be autonomously landing in case of need. Okay.
Thank you, Alessandro. One last question, short answer, please.
Yeah, good morning, Nico de Gelder. I have a question about the digital co-pilot. Obviously, he's interacting with the pilot on board, but you said, okay, he can also be delegated the RT task. Do you also consider the interaction, the teamwork between the digital co-pilot and the controllers? Is that being researched?
Between the digital co-pilot and controller, right? Yeah, so yes, it is still on the level of what we call the assistants. I would love, like, if you have more questions, we can discuss outside during the coffee break. But yeah, it depends on the assistant. So for example, if we use like ATC communicator, like automatic ATC communicator, so there is actually a direct interaction between, like the assistant and the ground, like the ATC ground. So I don't know if I answered your question.
Yeah, the question is more, okay, is there a need to know that the controller is talking to a digital co-pilot, or what are the issues over there?
Yeah, speaking about the ground controllers, for example, yes, of course, like it depends on the specific use case in terms of, like, as Alessandro said, during the capacitation, we can actually spread out this information through an ATC assistant to the ground saying, okay, this pilot is actually incapacitated. Yeah, this is one of the possibilities.
Thank you. I think we are done with this session. I would like really to thanks the speakers for their presentation, and also the questions that came through the audience. And of course, as it was mentioned, many of these presentations are also shown on the stands. So you can really, I entice you to go on in the discussion with the participants during the next session. And thank you very much all for attending this session. And we move on to the next session. Thank you.
Yeah, so thank you, Romeric, and thank you all the speakers. First of all, thank you very much for the content. Really, really excellent. I saw a lot of people glued to the screens. Thank you very much for keeping to the time. That is really appreciated as well. And again, guys, don't hesitate to go and visit the stands. And otherwise, we need to switch on our digital assistant that's going to track and trace you as you move through the lobby area. Yeah. Hey, have a great break. See you all back here at 11 o'clock. Okay, you can all start taking your seats again. We've been running this event very, very accurately, so don't want to spoil it now with the fourth session, where we're going to zoom in a little bit more on the human aspects. And whilst you're all finding your seats for that, let me introduce you to as well Barry Kerwin, a much respected colleague from Brittany, who will be the moderator of this next session. Barry, the floor is yours.
Thanks, Paul. Good morning, everyone. It's my pleasure to introduce this session on human AI teaming. I think we've already started this discussion this morning with projects like Darwin. And yesterday in particular, we had the EU Act on AI, which calls for human-centric AI. And also we heard the EASA categorization of how humans and AI might interact with 6 categories, going from today's machine learning through more collaborative approaches, all the way through to perhaps AI running the show with or without human supervision. So I think the question now is what will this look like? How do we translate human-centric AI into operational concepts? So to do this, we have 4 papers. We have one which is really on now AI, if you like. That'll be the first paper on speech recognition. And then we'll have 2 papers on more futuristic human AI teaming concepts, which help illuminate some of the EASA categories. And finally, we come to IFATCA, who's going to talk about what it will mean for the controller on the other end of working with an AI system. So without more ado, I'd like to invite the first 2 speakers, Thomas Rock and Jeremy Carroll of DSNA, to tell us about their system called Scribe.
Morning, everyone. Thank you, Barry. So as Barry introduced, we work for DSNA, so our organization provides air traffic control. And when people imagine air traffic controller, usually the first thing they think about is someone looking at a window or looking at a radar screen, right? But this morning, we're going to talk about the other aspect of it, which is this one.
Southeast 1071, contact to switch radar 135.680, bye-bye. 135.680, bye-bye, Southeast 1071.
It's not long, I promise.
Enter 6061, head identified, climb plan level 110. Sorry, 190, enter 6061.
So you can get by yourself some properties of it, right? Lots of noise, fast-paced messages, switching languages, different aircraft. What you might have not noticed, though, in this recording, there is a safety event, something that could lead to an accident later on. And so the question is, how do we deal with that, either directly or after the fact? And so over the years, if it works, yeah, people build a lot of advanced tools based on radar data. So you've got STCA to prevent collision between aircraft, EMSO to prevent collision with the ground, APW to avoid entering an area where people are firing missiles. Flight plan, all the flow management capacities to avoid overloading a sector, conformance with the flight plan, and closest point of approach to anticipate conflict. But all those tools are great, but they don't catch the information that is just in the voice at a given point in time, which is earlier on and which is more useful. And so what we've got as advanced tool for the voice, well, not much. We have recorders, we can replay the sound, but that's it. And so this is why we started working on Scribe. So what Scribe does is basically allow you to go from the audio, operational audio, to text. How well does it do it? Well, I was about to say 92% accuracy, but because Alessandro yesterday introduced you to what a word error rate is, that's basically 8% error rate. It does it in French and English because the DSNA, we do air traffic control in both, and for all flight phases and route, approach, and tower. The second thing that is really useful in that case is to be able to extract information from that text, like who is talking? Was it a pilot giving a read back to the controller giving a clearance to the pilot? What's in the message? Flight level, a heading, all that stuff. And so this is what Scribe does as well. That's the second part of the pipeline. And the last one, to close the loop, and you will see in the use case why it is useful, is that we can produce speech again, French, English with several accents, it's controllable. We can do English with Spanish accent, etc. And so this is a service that we built so that it's usable from everywhere in the SNA, either post-operation, so you can send the audio like 1 hour and get an analysis of it. We'll talk about that. Or you can use it for live situation, tactical usage. And I will let Jeremy present that.
Thank you. Good morning. So now let's have a look at the different applications we've made so far, starting with Elvira. And for those who were here yesterday, it will probably remind them another presentation made by our ENAV colleagues. I assume you're probably not familiar with Elvira, so I'll start giving you a quick explanation, a quick description of it. Elvira is a software that is used in the SNA by our safety analyst teams to basically replay a situation that happened on the controller working position. So thanks to that tool, they can see exactly what the controller saw, and they can listen to the audio recordings. And when there's a safety event, for example, the loss of separation minima, the safety analysis is mandatory, and they have to transcribe the recording. With the introduction of Scribe in Elvira, the analysts now have access to an automatic transcription, saving them tedious work, as you may imagine, hearing the recording we've heard earlier in the presentation. They sometimes have to listen to the recording several times to be sure to catch the correct wording, whereas now they just have to make light corrections. Scribe does not only make them save time, but also allows them to make deeper analysis because they can now effortless transcribe hours of recordings. And that's the thing they were not doing before because of the lack of tool to do it. Scribe is currently deployed and in use in many French centers. And there's ongoing works to create new at-scale safety-related metrics. So here is a few feedback on this use case. We have about 40 service requests per week. Scribe is used in 13 DSNA units and more to come. In 3 months, we've received 260 hours of audio to be transcribed, and we've collected 1,500 corrected scripts that could be used later on to improve our speech-to-text engine. Here you have some testimonies of the users, which are pretty great, saying that it's effectively allows to save time, but also make more efficient safety analysis.
Thank you. So leaving a bit the safety world, the next use case, oh, that doesn't work, is training of ATCOs. So when you train ATCOs, you've got a simulator, that's an automated system, but as of today, you still need humans to play the pilots. We call them pseudo-pilots. And usually a pseudo-pilot can handle between 10 and 12 aircraft, virtual aircraft, but on a heavy loaded simulation for an air traffic controller, you've got 30 aircraft. So you need 3 pseudo-pilots. That was a problem, especially during COVID, but it's still today. It's a resource, pseudo-pilot that is hard to find and expensive. And so the question that was asked to us is, can you automate part of their workload so that we need less pseudo-pilot to perform the same simulation? And so this is what Virtual Pilot Project addresses. So you just listen to the trainee air traffic controller, you understand what he says, you fill the system with that, and you get a response with the text-to-speech as if it was a pilot talking. So where we are in that project, we are currently providing the service to ENAC school that is reviewing it and testing it to maybe integrate it in their simulators. But we have a demo ready if you want to come and see us later at the stand. That's one.
Well, crosscheck is another application based on a simple principle. Now that we are able to transcribe live the frequency, why don't we build a safety net based on it? Sometimes, rarely, hopefully, a controller may miss a wrong readback from a pilot, or a pilot can take a clearance that wasn't meant for him because, for example, he has a call sign close to another one. And so the idea of cross-check is to make a comparison between an information that is passed through the voice with either another information passed through the voice, like on the wrong readback example, or with either system source information, such as the runway in use or meteorological data and so on. And whenever the system detects two different informations coming from two different sources, it will raise an alarm to the controller, informing him that something might go wrong. Obviously, with this use case, we expect a benefit on tactical time safety, as any other alarm that is displayed on the controller HMI. And which step are we crossing now? Well, we have a prototype that is fully ready to be validated. And we are currently reviewing the technical requirements to integrate cross-check in an operational environment. And to do that, we are trying the best suitable unit among the DSNA centers.
Thank you. And the last application, going even further on the controller working position, are called select and spot. So this is on the main controller HMI. What spot is about is basically, imagine an air traffic controller has like 30 aircraft on his screen. The first time the aircraft calls, the first thing you do is look at where it is, right? And so we already have a system to help with that. That's called an RDF, a radio direction finder. The problem with that is that it only gives you a direction, not a distance. So you have to triangulate. That's what our colleagues in MUAC are doing. But those systems are expensive. We are currently more removing them than adding them. And so the question was, can we do that based from the voice? Well, the answer is yes, because the pilot gives you his call sign. And if you're able to catch that and identify that and avoid confusion, then you can spot the aircraft. And the last one, which is spot, which is select, is basically filling the controller HMI directly from the voice. This is akin to what was done in the SESAR solution that Andreas talked about yesterday. This is basically the same thing. And talking about SESAR, by the way, the future for Scribe kind of is we will take part in a recently selected project that is called Dialogue, and we are really looking forward to be part of that. And that ends up our use cases for today. I'll leave you the conclusion. Oh yeah, sorry. The status of select and spot is we did some validation with air traffic controllers in our lab, but it's not. It's the last one in the timeline, definitely.
Well, that was a glimpse of our work so far. And now, if you want live demos of every one of these use cases, feel free to come and visit us at our stand. Thank you.
Thank you.
Thanks very much. So we're making good time. Our next presenter is Simone Pozzi. He's CEO of Deep Blue. Deep Blue is known to a number of you. They support a lot of SESAR projects, for example. And we're going to move into the future. So Simone is going to tell us about the Haiku project.
So, good morning, everyone. We'll be speaking about Haiku. It's an Horizon 2020 project. I'm going to cover three topics. First, the overview of the project, what the project is about, which are the distinguishing features. Then I'm going to deep dive on one of the use cases, one of the practical applications. And the third one, we are doing some transversal activities geared towards AI assurance. So I'm going to cover a couple of slides on that topic too. So the goal of the project is to develop intelligent assistance for pilots, air traffic controllers, airport safety managers, and so on. If you read this definition here, this is really our goal. The words I would like to highlight are the human-centered, those two words, because this is really what we are trying to do and to distinguish ourselves in putting a lot of resources on making sure that every innovation that we introduce is really centered on the needs and values of humans. So this is really the key challenge, to have intelligent assistants that are value-based, considering needs, abilities, and limitations of humans. It's an ambitious statement, and I'm going to describe a couple of ways in which we are trying to do that. The first thing is our approach. So when we started ICU, even at the proposal stage, we started from the operational goals and needs. So we started asking our end users, our stakeholders, okay, which are the pain points, which are the opportunities for AI? Then we moved into the AI field, which are the potential AI solutions that we may want to apply. We didn't stop there, because here it's the moment where I should say we are not going to substitute humans. We are here to develop human AI teaming, and it's true, but it's not that simple. As soon as you introduce a digital assistant, the work is going to change. So yes, we want to keep pilots in the cockpit, but their work will change a lot. And I don't know, from a human factors point of view, if it is still the same job. It is still piloting when you are monitoring systems that are sending inputs, speaking with controllers, and maybe there's no controller there. There is another digital assistant. So what we want to do here is to see whether this future is desirable from a human point of view. If you ask pilots, if you ask controllers, you know what the answer is. So we are trying to find a consensus area. What do we desire as humans? What do we desire as professionals? So this is the palette I have over there. Doing the same job with the digital assistant is not the same job, especially if we look far ahead into the future. How are we doing that? We needed to bring on board the good mix of expertise. So these are the partners in the project. We have human factors, we have end users, navigation providers, technology suppliers from within aviation and from outside of aviation. Then we decided to cover a broad range of different potential applications, our use cases. We call it the Swiss knife because it's really a variety of cases. Some of these are looking into futuristic scenarios. Some others may be applicable tomorrow, or it's more for safety management of airports, so it's going to be applicable tomorrow, really. So we have one use case about assistance to pilots in startup events led by ENAC. Second one, it's again for pilots. It's route planning and replanning led by Thales. Then we move to the UAM part, so drones operating in urban environment led by Linköping and LFV. Intelligent assistant for digital tower controllers, so ATC sequencing led by Skyway. This is the more near-term scenario, assisting safety managers going through safety data. Luton Airport led by EUROCONTROL and engineering. And then we have a sixth use case from the passenger's perspective. When we wrote the project, COVID was still around. So this one is really to monitor the spread of infectious diseases in airports from the passenger's perspective. We are going to deliver outputs. We are midway in the project. We're going to deliver outputs on 3 strands. So the intelligent assistants, we want to develop them. We want to validate them. And we have done the first round of validation for all of these, all of the 6 assistants. Now the second round is coming next in a few months. Then we have the AI assurance part. So we want to try and test approaches, processes, methods to do human factors assurance for AI. It's a different job. Some of the techniques that we have today may be applicable, some others maybe not. So we are working on explainability, and we are working on a human factors assurance process, testing it out in the 6 different use cases. Then we have the societal aspect. That's the third pillar. This is what I was referring to, what we desire as society. So it includes the design and assessment of new human roles, whether, again, we like them or not from a societal point of view. It also includes the analysis of the implications for liability and ethics of those concepts. They may be safety related, those implications, they may not be safety related, but still we thought it was a good idea to analyze them, to assess them. And then we are also trying to assess whether safety culture is going to change. We are quite proud of our safety culture in aviation. We want to keep a good safety culture even when we introduce a new teammate. And the teammate is going to be artificial, is going to be an intelligent assistant. Is this going to change the safety culture? I'm stressing this point a lot because any question on this, I will be happy to give it to Barry. So I'm trying to to attract questions on this point. So let's go deep into one of the use cases, the one led by ENAC. It's on the assistance in start or response. We're talking about single pilot operations. So far in the future, we have just one pilot. For the moment, startle events are being dealt by teamwork, by training. Now, in the future, we have just one person, one pilot. We thought it was a good idea to provide assistance. So the key research question is, how can AI support a single pilot during startling and surprising events in the cockpit? And we came up with the idea of Focus. It's a real-time assistance to pilots to detect startling events and to help them regain situational awareness and control of the aircraft. So the timeline of the typical case would be, you have an aircraft landing, there is a lightning bolt, it's a surprise, the pilot is startled. Focus detects by physiological parameters that there is a startling event, and then it steps in to coach the pilot in regaining control by attracting attention to the relevant instruments and to help the pilot self-detect the startling situation and get out of it. So it's basically a stress coping mechanism in place. So we have three functionalities: detection of startle and surprise via physiological parameters. This is the part where we are trying to train our artificial intelligence functionality to detect and differentiate startle from surprise, for instance. Then we have the idea of biofeedback to help pilot regain control, so get out of the stress of the blocking, freezing condition. And then we have the augmentation of pilot situational awareness by drawing the attention to the relevant instrumentation. This third part, for the moment, we have a concept is still being developed. So it's the first two we experimented that, we tried them, the third one is still ongoing. So this is it for the use case, for the practical application. I'm going to spend a couple of more words on the pillar on AI assurance. So how we are trying to do AI assurance, and on the design and assessment of new roles. So AI assurance, what we are trying to do is to assess all the use cases from the point of view of safety, security, regulatory compliance, liability, and human factors. So all of these aspects, and ethics too. We are trying to do it all together because we want to see whether there are interactions between these different KPIs. And of course there are, because you may have something that is safety relevant that may have implications for liability, for instance. So I'm giving you one example, again, from use case one. For instance, we know that our Focus assistant may detect some events, startle events that are not real, so false positives. That's the biggest issue we had during the validation, for instance. So it gives a notification to pilot that is not necessary. What is the safety impact? Overload due to unnecessary notification. What is the human factors impact? There is a problem of trust. If you, as a pilot, keep getting, the cry wolf effect, then after a bit, you don't trust the assistant. What is the liability problem? There is a product liability on the producer of Focus, but there is also a corporate liability risk, because you need to train pilots for the new assistant, to train them for the fact that the new assistant is not going to be perfect. It's not, we know that it's not going, there will be false positives, and maybe also some negative ones. So you also need to develop training for that. So this is the way we are trying to roll out, to do the assessment, the AI assurance part, trying to cover all the KPIs and see where are the interaction points. For the assessment, we are not using new methods, new techniques. We are trying to use the gold standards, the techniques that we all use. Our goal is really to see how they could work together, especially in the first development stages when you are checking the trustworthiness of the application. Then I'm going to finish on the impact on the human role. I mentioned that doing the same job with a digital assistant is not going to be the same job. So one strand of work is to analyze how the job is going to change. And of course, there is a huge brainstorming activity, forecasting activity here. We don't know. I mean, we have to create a new scenario 20 years ahead and imagine how the world is going to be different. From that, we are trying to derive the skills and competencies that are needed for pilots, controllers, and all the other aviation professionals, and to derive the new training requirements for pilots. At the present stage, we have done this process for the 2 cockpit use cases. We are trying to do it. We are also doing it as part of training courses that we are doing in Luxembourg at the EUROCONTROL Aviation Learning Center. So it's still trying to finalize a methodology. The end result is really to define which are the new training requirements on the usual suspects for CRM in this case. So is decision-making different? Which are the training requirements for decision-making? Leadership. How do you communicate with the digital assistant, knowing that the digital assistant is going to communicate to another digital assistant that is going to communicate to another human? So again, it's exploratory. It's not consolidated yet, but we thought it was a good idea to try and cover this area too as part of ICO. So thank you.
Thank you, Simone. We're going to stay in the future a little bit. It's my pleasure to invite Dmitry Kirov, who's a principal research engineer at Collins Aerospace, to tell us about the JARVIS project.
Thank you, Barry, for kind introduction. It's really great to be here today to share our vision on how artificial intelligence can support us humans in managing air traffic. How can it help us to have higher performance in ATM-related tasks, such as resolving conflicts in the airspace, communicating with ATC, performing airport operations, and many others. So we all know that AI is a disruptive technology in aviation, and many things still have to be understood. In the area of ATM, it's really important to be human-centric, we believe. So to have the AI technology accepted, trusted by its end users, and also approved and certified by regulators, because many of our applications are safety critical. So today we introduced JARVIS, just a rather very intelligent system. I'm sure some of you may be familiar with the Marvel universe, and maybe the name JARVIS rings a bell, right? So recall Tony Stark, the Iron Man, and he created an AI assistant for himself. So it's an assistant for a superhero, essentially. Well, it's the same here. Just we have our own superheroes. These are pilots. These are ATC. These are airport staff. I was not expecting this slide here, but I will reshuffle. So anyway, that's some older version. So let's just switch. So it goes without saying that ATM is undergoing this process of digitalization nowadays, which will revolutionize the aviation ecosystem and open various opportunities, technologies, applications, and step-by-step raise automation levels up to very high ones. And so JARVIS project, which is a European project funded by SESAR joint undertaking, takes up this challenge. The goal of JARVIS is to develop 3 digital assistants based on AI technologies. These assistants are to team up with the human counterparts and ensure safer and more higher performance operations of human users in complex scenarios. So we are adopting human-centric approach, and the ambition of JARVIS is to take first steps towards automation level 4. We will not get there in this project, but we're taking steps towards single pilot operations in the future. We are being more pragmatic. We're looking at something, reduced crew operations for now. We're looking at what can be done today. Importantly, we want to be certification ready. So I will speak a bit about that a bit later. So the project is 3 years long and kicked off a bit less than a year ago. So many things are still to come. Here we present some first results and the concept. So it's a pleasure to me to present this on behalf of all our great partners here. So we are 16 partners from 9 European countries. Collins Aerospace is the coordinator of the project. I would also give a specific highlight that we recently welcomed also EASA on board to join our team. And together with the EASA AI research team, we will be assessing the maturity progression of JARVIS solutions and assess their readiness for eventual approval and certification. And we will also work towards extending the contribute with our lessons learned to the future versions of the AI concept paper, which is really exciting and important. And let me first focus on the project scope. So as I said, this is about 3 digital assistants in 3 domains. We will zoom in to every assistant in a few moments, but let's first see what they have in common. The common goal is to increase human performance, situational awareness, capacity, operational efficiency, to reduce the workload, to be really, again, we are really human-centric. We aim to raise levels of automation and to be ready for approvals and certification, both by end users and by certification authorities. So zooming in, one of our solutions that we are working on is airborne digital assistant, which is coming from the name, is to be deployed in the flight deck and assist pilots before and during flight in several functions. So the scope of this can be very large. We focus on 3 use cases. One is support with ATC instructions management. So it's an AI-enabled speech recognition function that processes incoming messages from ATC, checks them against pilot readbacks, and if there's a mismatch, an alert is raised. And the system also keeps track of incoming ATC messages to send reminders to the pilot at necessary times, which can be very useful in high workload, high traffic situations, for example. Another use case is support with flight strategy assessment, where the assistant would constantly monitor the situation with the ongoing flight strategy against external events such as weather conditions, air traffic conditions, state of the aircraft, to assess the risk of the existing strategy. And if this risk level crosses a certain threshold, then again, an alert and an explainable feedback can be provided to the pilot on what's going wrong, what can be, and also suggestions to modify the flight strategy to successfully complete the flight. So this can take the form of suggesting, for instance, nearby airports or runways to land. What's interesting about this use case is that it will be based on automated reasoning, which is a different AI technology, so-called good old-fashioned AI, let's say, which is particularly interesting from the AI assurance standpoint, because existing guidance is not yet covering such technology. Last but not least is support with predictable approach and landing. So it will use historical and current data to predict the runway and the approach trajectory. The TRL target of the solution is TRL 4 towards the end of the project. And again, the goal is to enable reduced crew operation and in the future also move towards single pilot operation. The ATC digital assistant instead would assist controllers in their roles, tasks, operating environments, and scenarios to reduce their workload, improve performance, capacity, operational efficiency, and of course, maintain the safety level. So this assistant will pave the way to cooperative human-machine execution of ADC tasks. We have several use cases. Conflict resolution using AI, which will make proposals to the controller how to resolve incoming conflicts. And upon acknowledgement of the controller, the information shall be sent also to involved aircraft. So we raise here the level of AI, the level of automation. So in EASA classification, we're speaking about level 2A here. Other use cases include data quality assurance, automation with AI, tactical recommender, which can propose opportunities for ATC, such as shortcuts, for instance, and related risks, and forecasting short-term air traffic. Again, this solution targets TRL4 and includes several AI technologies, including supervised machine learning and also reinforcement learning. Airport digital assistant is perhaps something to complement the context of this session, which was not discussed yet, and it's very, very interesting. So here the goal is to provide an alert system powered by AI to take mitigation actions and achieve more predictable airport operations plan. The use case would, the solution would focus on computer vision technologies to execute certain functionalities, including safety-related functionalities, which are detection of foreign object debris, FOD, wildlife in the runway safety zones, detecting taxiway incursions by vehicles, and also some functions for increasing operational throughput of the airport, such as predicting aircraft turnaround time, predicting passenger flows in the terminal, to increase the overall operational efficiency of the airport. Here, the ambition, the target, is to reach TRL6 at the end of the project. So this solution is coordinated by Athens International Airport. We have some colleagues present at the forum, so they will be happy to provide further information on this. I would also linger a bit on foundational AI capabilities. So what we do in JARVIS is developing AI solutions. And of course, on this way, we will learn a lot of new things. We get a lot of new knowledge. And we have a transversal work package in the project, which aims to establish a common methodology for using AI in JARVIS and collecting all knowledge and lessons learned from different solutions, sharing them between the partners, and also sharing them externally in the end of the project, sharing them with you. For that, we will be delivering 3 white papers in the end of the project, which correspond to the main pillars, foundational AI capabilities that we consider most important in the context of JARVIS. One is on assured AI design, another one is on human AI teaming, which is the topic of this session, and last but not least is the white paper on big data and cloud infrastructures. So our team will be studying and following the emerging AI regulation, including EASA AI roadmap and the concept paper, EU AI Act, and others. And we will be working together with standardization regulation authorities, including EASA. I will speak about it in a moment. And we will also interface for example, the EUROCAE Working Group 114, joint with SE G34. Okay, so coming back to what I anticipated about the EASA collaboration. So this is what we consider one of the keys to success of this project. Our goal, so you've seen the TRL levels that we aim. It's TRL 4 to 6. So of course, we do not claim to have certified solutions in 2 years, right? So our goal is to facilitate future approvals of AI-enabled ATM systems, to understand what are the gaps and how existing regulation, standards, regulations, procedures will be impacted by AI. SESAR solution package includes several relevant deliverables, so-called stand and reg. Every solution will prepare these deliverables to assess these gaps, the impact of the technology. And together with EASA, we will review these deliverables and having the goal of assessing the maturity of each and every solution in JARVIS and each and every use case, focusing on AI-related aspects. Beyond that, we want to contribute to AI research, to the advancement of the AI concept paper of EASA by providing our innovative feedback from our solutions. Together with EASA, we have identified several critical topics to explore, which include human AI teaming and also AI technologies, which are different from supervised machine learning, which is quite well covered in the existing concept paper. So this could be reinforcement learning, automated reasoning. And so we have down-selected several use cases in JARVIS that we will closely follow with the EASA AI research team to explore further on these topics. So I would leave you with these takeaways from this presentation. So AI clearly will shape the future of ATM and will impact regulations, standards. We all know this. There's still a long way to go to understand a lot of things, how it can be made trustworthy, how it can be certified. In JARVIS, we take up this challenge by developing AI-based digital assistants to assist different ATM actors, pilots, ATC, and the airport. We will gather new knowledge about what we learn in the project, and we will be sharing it across and also externally to enable future maturation of these technologies and the maturity progression, the TRL progression. Finally, we strongly believe that identifying early the certification paths, approval paths for AI is the key to success for adopting these technologies in ATM. Thank you.
Thanks very much, Dimitri. Our final presenter, last but not least, we have Benjamin van der Sanden, who's an air traffic controller at Schiphol Airport. He's also on the executive board of IFATCA, the International Federation of Air Traffic Controller Associations, and he is Executive VP Technical. Is that correct? Yeah. Which means he represents the interests of controllers worldwide on operational and technical issues. Benjamin.
Thank you, Barry, for your introduction. Let me see. There we go. So just quickly, for those of you who might not know what IFATCA is the worldwide organization representing controllers in 120 countries, just a bit less than 40,000 of them, a non-profit organization that works intensively with agencies like EUROCONTROL, ICAO, many others as well. So that's a really short introduction. If you have any more questions, please come talk to me about that. So how does IFATCA look at the implementation of AI? So we have made a working group called the Joint Cognitive Human-Machine System Group. Not a very catchy term, I must admit, but we're still looking for a better name. So if anybody has any suggestions, please approach me as well on the lunch break. So this group is looking exclusively at the role of automation, AI, and how it interacts with the human in the operation in ATC. So what they've been doing in history has been providing guidance materials to controllers. They've been starting writing on automation in 1997, and these documents have evolved and until the most recent one, which is still being drafted at the moment. So this is the history of materials. I'll go into the guidance material that is currently being drafted a bit more later.
But the traditional paradigm of automation was always that humans are better at some things and machines are better at others. And now, of course, with the new paradigm, I'm very happy to see that a lot of presenters, a lot of the tools that are being shown here do have that new paradigm in mind, where you augment each other rather than aggravate each other. So the research shows anyway that the combination of parts, components, machine and human in the system produces better results than the individual parts. So it used to be human versus machine aggravation. We don't want to have to manage the system. We want the human and the machine to complement each other, become better together. And I'm very happy, like I said, also to see that that is the direction of travel at this forum, that most of these tools have the human in mind. So we don't want to devaluate the human to justify the machine. We don't want to criticize the machine just to rationalize the human. We welcome new technology, but we are focused on design principles that help the human perform better. So, as I said, the guidance material is being drafted. It's not yet completed. However, some key points can be distilled. So as a federation, we've identified 5 levels of challenges to implementing AI and machine learning in the wild, in the ops room. So the first level, political, regulatory, you can already see progression like the EASA AI Act, but there are still other concerns like state sovereignty, the agreements on the sharing of risk when implementing these tools, and the complexity of regulating AI and machine learning tools. Next level, ANSP business. So there are concerns about cost effectiveness, the increased cost of cybersecurity, the vulnerabilities that you need to cover when your tools get so complex that they affect safety levels. Aviation's reputation throughout the years has been built on a safety first principle, and we must make sure that that remains the case, that we do not devalue the trust that people have placed in the aviation sector by being too hasty with implementing these tools. Technical challenges, the curse of dimensionality, you'll be familiar with that. The rate at which complexity increases, the rate at which bandwidth is necessary to process the data involved. Obviously, that is a security risk, but it's also a cost risk. And not unimportant from a controller perspective, what about when the system fails? What are your backups? How do you address that in an environment where the operational is supported by the system to such an extent? What is your fallback? So operational challenges, function allocation issues. So how do you divide a task between the AI tool, between the controller? Who is responsible for what? What is the level of responsibility of the tool? What happens when a system fails to execute its tasks and then the ATCO has to take over? The air traffic controller, sorry, ATCO is a jargon term. And the air traffic controllers, how do you keep the ATCO in the loop? What new types of errors are we going to see that are due to the lack of understanding of how the system works? Can the air traffic controller still understand the solutions that are being presented to them? Can they still analyze whether the system has suggested a correct or feasible solution? These are all very important questions that need to be addressed. You might have a concern about ATCO de-skilling. You are creating a tool that was taking tasks from the controller and executing them in its stead. What happens to the skills of the controller? Do you keep them current? And how do you do this? What does it mean for the training of the controller, etc.? Let me see. Oh yes, and the competencies for the air traffic controllers. Air traffic controllers are selected on a certain set of skills, a certain set of personality traits that are, I don't want to say, it's a highly skilled, highly pressurized job. What happens if you are creating tools that
take so much of the cognitive load away that you get cognitive underload, and you have to manage the vigilance boredom as well. What happens when air traffic controllers get bored? They're not selected to be system monitors, they're selected to be controllers. So IFATCA has created policy. I won't go through everything here because the slides will be available later, but there's a couple of key points that I want to highlight. So it is a policy of IFATCA that we believe that artificial intelligence and machine learning should only be implemented as support system and shall not replace the decision of the ATCO. This is to guard that vigilance boredom dilemma that I was talking about. Where NATCO is responsible for decision making, it should always be the case that the ATCO has the capacity to manage their area of responsibilities. We don't want to end up in a situation where the workload, because of AI support or because of tool support, has become so high that the ATCO could not manage without the support, because then what happens when the system fails? There's validation, of course. In case of disruption, appropriate procedures shall be put in place to assist ATCOs in emergency situations. A special attention to airspace capacity, safety risk assessment shall be carried out. This is all pretty standard stuff, but yeah, it's you can have a look at it later to reference the slides. And the most important one, in my view, AI systems or applications in air traffic management shall be human-centered throughout the whole development process. So what we mean by that, I will go into it later, but what we mean by that is that the design concept should always be focusing on augmenting the human workflow and not replacing it. So what is the way forward according to IFATCA? Well, first of all, human machine teaming. Obviously, we've been talking about that. And we want to say, see augmentation. So as technology becomes more complex and autonomous, it's crucial to provide guidance on how these systems and humans can work together. And the focus should be on designing systems that integrate seamlessly into an operator's workflow. So what we do not want is to have to manage the system. I already mentioned this earlier, but to take time away from the crucial, from a controller perspective, time is almost always your most scarce resource. So what you do not want is that you are dealing with the system instead of dealing with the traffic. So our principles for operator-centered design are the focus on designing and delivering operator-centered technology, the human in the center. The trade-off between augmentation and assistance must be carefully balanced. So empower the controller to make the decisions rather than take them away from them. Aim for a diverse set of use case scenarios. Develop and utilize several technology-specific and operational metrics so that you can measure what the system is actually doing afterwards and evaluate whether it's doing what you want. And test the system in isolation and also in cooperation with the other systems. So how does it interact with your planning system? How does, if you have a conflict, a deconfliction tool, how does it interact with your planning? How does it interact with your tactical solutions in coordination, etc. Project implementation steps. First of all, project rationale. What problem are you trying to solve? Is the tool correct for the problem that you're trying to solve? Are you looking to replace controllers, or are you looking to help them do their job? You have to identify the affected competencies of controllers according to the ICAO list. There's an ICAO competency list that we refer to when training controllers, when selecting them. So how does the implementation of the system affect these competencies? And you need to consider maybe training, extra training, stuff like that. Cognitive task analysis, so understanding the task challenges and cognitive strategies that controllers use to manage their traffic. So according to the ABCDE model, assessment of the situation. So what is actually happening? A balance of your constraints and resources. So what tools do I have at my disposal to solve the problem at hand? Communication, how do I communicate what I want to get across? Decision-making and planning, and error detection, very crucially. If the the system and the human together make a decision about a certain solution to a conflict, can the system then, with new input, realize that there has been an error and produce a new result? So challenges and considerations: acknowledge that there are challenges in introducing new technology, safety concerns, the complexity of the system, the shifting of costs from perhaps labor to maintaining the system, the bandwidth, the contingencies, what is going to happen when the system breaks down, etc. Impacts on the operator's abilities and adaptability, as well as the legal responsibilities. Very important, crucial factor for us is, what does it mean when the system tells me to climb an aircraft and a conflict results? Am I responsible, or is the system responsible? Is the engineer responsible? The regulator? This is a very important point for us, that this is very clear before we start operating in real ops rooms with this kind of tool. So in conclusion, introducing new technology in operations room is a continuous process. It keeps happening. It's ongoing. We want to emphasize the need for the careful consideration of human-machine interaction, the operational needs of the implementation, and adaptability. So we propose this framework, this process for efficiently integrating innovative technology in the ops room, while addressing the associated challenges. We really hope that we can welcome new tools that help us do a better job than we're doing now, help us produce a safe and orderly sky. I think there's a lot of potential, but I also think there's a lot of concerns. So thank you for listening.
Thank you, Benjamin. So a lot of food for thought there. So I'm just going to throw it open to questions now, to the four speakers. Please.
Thank you. Theodore Kuritzman from IFATSEA. A question for Benjamin. First of all, thank you very much for raising the issue of contingencies, because it's something that we probably have to face in the future. However, you mentioned a lot of concerns that you have with regard to the introduction of AI in the ACC room or the tower in ATC. I have the feeling that the skilling and contingencies are the top ones. Is that feeling correct? Do you share that?
Thank you, Theodore, for your question. I do think that de-skilling is a huge issue that we would need to address. If you get the task allocation wrong, and you take the real process of solving conflicts away from the controller, are they still going to be able, if the system does eventually fail? Because, well, I know that a lot of people here will say, no, we can make sure that the system never fails. But from an operational perspective, all systems eventually will fail at some point. And then you're in a position where maybe the air traffic controller isn't capable of intervening anymore. And just to tie into that, I think that you have to be really careful by introducing tools such as these, that you do not limit the resilience of the ops room. The aviation is a resilient system because of the human in the system. Because if one of my team in the tower isn't feeling well, somebody else can jump in and take over, and the system continues and is resilient. Now, if the AI tool is a significant factor in how we are handling traffic, and it fails, there's nobody to jump in. There's no resilience. So less of it anyway.
Maybe just to complement Benjamin's answer. So regarding the skilling, one related challenge is also overconfidence in AI, because we all speak about AI assurance, making it trustworthy, but what can eventually be developed by some users is overconfidence. Especially this is important for when the level of AI, level of automation, level of responsibility of AI goes higher. Right? So the person may think, the user, that the AI has it covered, while essentially it does not. So, and the human user is not aware of that, or AI fails to do some tasks, but fails silently. Okay, and again, the user would be pilot or control. It doesn't know that actually a failure has happened. So that's what we consider in JARVIS also an important aspect.
Maybe a complementary question for Benjamin. One of the things that he said that attracted my attention was try to avoid scaling the operations beyond what would be then resumable by a human. But I would argue that we already passed that point, and recent ATC system failures in the UK, I don't want to point fingers, but have demonstrated that that we have already passed that point. And if we think, in the Eurocontrol building, if we think about initial flight plan submissions, without that service being operational, I don't think air traffic in Europe would be able to sustain these levels today. So I think, of course, AI has different implications, but where do we draw the lines of capping the potential capacity of our airspace to what's humanly possible?
Thank you. There was a question.
Okay, so Rita Shamodi from EUROCONTROL and SESAR Scientific Committee, and I would like to chip into this discussion, asking Benjamin also about how the different roles can be shaped. I was particularly impressed by your comments saying what happens if we take away this kind of excitement or this kind of mode of working, what the ATCOs do now. And I would like to tie this into atomic energy. So all through these 2 days, I feel like it must have felt a lot of years ago when atomic energy was invented and people started to see, okay, where can we use this? So we are not having a problem now and finding a solution, but we have a tool and we are looking through all the different pieces. Where can we fit this in? And I think we will naturally come to the phase when we will finally end out in 10 years, 15 years time, when we'll exactly see where this fits. But until then, I find it very interesting to see the spectrum. And this is the point of my question from the human side, how probably there is a paradigm shift going on, and we shall also consider not the fact that we have some kinds of operation for the air traffic controllers and we adapt our tools to that, but see that what the tools are capable of, and also daring to shift what we use air traffic controllers for. And I'm quite sure that just as with atomic energy, this will be more like a phased and a fragmented solution and a detailed solution. Probably some parts we will use supervisors, and then we will also definitely need what you just replied to in the answer to the first question. It will be a detailed analysis of, we will need some people who also are still capable of doing the whole thing as well. So I'm just curious what you think about this human side of that. Thank you.
Benjamin.
So just to summarize, you wondering, am I still going to enjoy my job, basically, right?
Exactly, and maybe we should not be focused on letting people enjoy what they have been doing now, but creating new jobs and new roles where they can enjoy something else. It's just like when we had the weaving machine, and then we will have supervisors who will enjoy it in another way, and then we will have other roles where it will be a bit different.
Yeah. Okay. Thank you for the question. So for me personally, I am an air traffic controller because I walked into the ops room and thought, this is amazing. I'd never want to leave this place because there's always something happening. It's always, you're always having to be flexible and always jumping into the situation just head first and getting to the other end of the day, having managed all of it, right? I think there's a lot of implications if you're going to change the dynamic of the job considerably, that there might be a lot of people that would leave it. I don't really see myself as a system monitor.
Exactly.
Exactly. So, I mean, that's not really an argument, you know, in an ATM context, that's not really an argument to say, yes, you should or you shouldn't do it. But I think that you're going to have a different type of person in that seat.
Exactly, and you would need to have a phase-out approach where you can keep those people who are very best in doing this kind of thing and then build it up slowly into something else if we will have new systems for that. Thank you.
Thanks.
As somebody who's worked in both nuclear power and air traffic, I think controllers have more fun. I can just say that. There was a question there. Thank you.
Yeah, this is Max Scheck from the European Cockpit Association. First of all, basically we could just replace pilot with controller and take the presentation from Benjamin. It mirrors exactly our concerns, some of the issues we're dealing with. And to piggyback on what the controller from Eurocontrol just said, a question for Simone. The profile, the aptitude testing, and in the pilot world, there's very strict aptitude testings that are now required. We have an existing population of pilots right now. If these things change, Simone said, well, we're looking at new training requirements that will come in the wake of these changes. Are you also looking at the job profile that was just addressed and some of the gaps that need to be filled in the, I mean, there's ways potentially to make the life of a pilot and a controller still interesting as you're sitting in that position and AI is taking over some of the things we do. But even more important, are you already foreseeing the new aptitude, the new profiles that these individuals will need? Because it takes several years to train a controller, it takes several years to train a pilot. And we cannot at some point just say, okay, now we have a whole new job and we have 40,000 controllers and 120,000 pilots that have been selected for the old job, but now we need the new ones. So are you actually having that on your Haiku project as well, as you're looking at these new aptitudes and skills and profiles that we need? Thank you.
So thank you. It is exactly the point of the strand of work that I spoke about. That's what we are trying to address proactively, not waiting for the moment when we realize that, okay, now it's a new job, but we still have selected the old person with the former competencies and training sets, and now it's a new job. So we no longer have a good match. So we are trying to do that. Honestly, it's again, it's exploratory because you have to forecast and imagine how the job is going to change and also everything around the job. So from selection to initial training to teamwork with other professionals that are not pilots. So we are forecasting that, but we are trying to address exactly that point. And if I may, one of the paradoxes on the what happens now, we are trying to do more complex operations with less humans in a more extremely demanding situation. What happens is if automation fails, what we found in this strand of work on training is that you have this paradox that you need to raise the bar for the entry level of pilots and controllers, because today what happens is that you call in your colleague. So you have teamwork, you have the human stepping in as a team to compensate and to try to slow down the system till you can control it again. In the future, if you have just one person with digital assistants trying to do that, you have this paradox that you need to have an extremely competent individual to do it on his own or her own. So we have this paradox that sometimes we say, okay, we are going to do that, to use less resources and do more, but then you're raising the bar for the new entrant because you take away all the on-the-job training with the expert person sitting next to you.
Thanks, Simone. New questions, please.
Hi, I just wanted to say something while I was hearing these presentations and the helpful discussions recently. These things are not new. an air traffic controller in the 50s had a completely different job than he has now. A pilot in the 50s needed to do specific tasks and have different skills than a pilot needs now. I remember a discussion I had with a radar operator on an aircraft where he was telling me that he didn't like the radar image that he saw because it was just filled with digital track information and didn't have the raw video from the radar where he could accurately decide whether that was a target or not. What I'm trying to say with this is AI is not really making a difference in this. It is a tool. We still need to be careful about introducing these things as we have been doing as a community with all of these new technologies. But we shouldn't be necessarily afraid of AI taking our decisions or our capability of keeping aviation safe. It is a tool, that's it. We just need to properly understand it and make sure that it's going to operate in a safe way.
Thank you. Anyone like to respond? Simone?
No, you are fully right. What may happen is that the life cycle, the rate of innovation may pick up. So in the past, we were able to, from the human point of view, it happened exactly as you described, because the life cycle, the rate of innovation was slow. So you had time to have new entrants, to adapt your skills. Now in aviation is more or less still like that, but in other sectors we have seen a rate of change that is too fast for humans to cope with that naturally, like on the job. So you need to put in extra organizational accompanying measures or institutional, policy making measures to make it happen, to support the domain, the industry in making this change. But I fully agree with you. It's not different. The rate of change may be different. That's what we're seeing in other industries.
Benjamin,
if I could just complement that, and to answer the comment, I want to emphasize that controllers are not afraid of the tool, but we just want to make sure that when you design the tools, when you design the systems, you keep the end user in mind, and you don't make the design about the tool, you make the design about the user. That's all. That's the message.
Thanks. Please.
Yes, Thomas Buchanan from Skyguide. First of all, thank you very much for a very interesting session. Still wondering if teaming is the correct word. For me, teaming would mean that you've got the machine, which is the equivalent of the human. We're all talking about the human failing, or the machine failing, but I was going to ask, what happens if the human should fail? Would we accept the machine to take over for us? And there are many other questions as well that go down the same or similar paths. Is it only the ATCO? Sorry, I'm using your slang word. The air traffic controller is going to be impacted. Are we looking at ATSEP, the community, and globally? What is going to change? What does the future system look like? And there you can go down to ethical questions again, like Tesla has been doing in the States. So if I may quote one of the Swiss ministers, I think it's important that we progress as quickly as possible, but as slowly as needed to get this correct.
Thank you. I'll just mention we had a meeting last November with the FAA on human AI teaming, and they don't like the term teaming. They hate the term AI teammate. They want to avoid what they call anthropomorphism of AI. To many people in the FAA, they think it's just more automation. So they're quite careful about these terms, and I think we're still trying to find the optimum term here. Would anyone from the panel care to join in? There's lots of smiling faces. So I think it's one to watch. But thanks for the comments. So okay. Any other questions, please?
Thank you. Danny van der Biest from IFATSEA. I have a question with regard to the human AI partnership that was well presented in the haiku presentation. But there is an ontological distinction between the human and the AI agent. And one of the examples that comes to my mind is that what would be the logic of punishing an AI agent when criminal law comes around the corner. So, but to make my question clear, is your project also including paving the way to a specific model for attributing liability, for instance?
What we are doing, we are trying to assess liability shifts since the very beginning of a project. So we are not changing the current regulatory framework. So the framework stays the same. We are considering, the new frameworks, regulatory frameworks on AI, but the liability attribution is the one that we get from the regulatory framework. What we are doing, we are analyzing the shifts of responsibility of liability due to the concepts that we are trying to introduce. And we are offering that to the designers so that they are aware that sometimes with some design options, you may also change the liability profile, and maybe you don't want to do that. Maybe you want to stay with the same liability profile. So to us, it's another design dimension, liability. So that's what we are currently doing. And the earlier you tackle it, the better, because of course you still have options. And again, if you go for one option, maybe you're not changing anything, so you don't get pushbacks and problems from all the parties involved.
Thank you very much. Very interesting. Yes. Well, two things. One reflection. I think from the experience we're gathering is that sometimes we are kind of very absolutists. I don't know if that's the word. It's either everything or nothing. And I think that the detail is in use cases and in the details of what we're going. So whatever model we go for, I think that we need to allow for flexibility because the use cases vary a lot, and they vary a lot even in operational context between busy and non-busy situations, etc. However, I would like to maybe go and ask the JAC within the Scribe. It was a good example of one application, voice recognition, and then that it's used in a number of use cases. And there, one of them was mentioned into be kind of a safety net in identifying possible mismatches between what is being said by the controller and what is being read back. However, there are other levels nowadays with mode desk downlink, etc., where that information could be captured otherwise. So the question I would like to ask is what is the process you are using to include this application within teaming or within the interaction that is being used by the operator, because it's not an absolute one. You have an application and you need to adapt it to the use, which I would imagine that you would need to take care at various levels. So maybe a short comment by the JAC of how, once you have identified the use of a typical application, you go and look at how to integrate it within a particular operational context. You were identifying 3 or 4, maybe an example of one would be enough. Thank you.
All right, so to decipher the question, if the question is, do we include data that doesn't come from the voice inside the system? The answer is yes and no. The yes part is where there is weakness in the speech recognition, or more than that, if some information is absent. For example, the absolute thing we want is to match the right aircraft when we analyze a message. The thing is, the system only knows the full call sign, but sometimes in the voice, you get the short call sign, meaning some information is not there. It's not even that the model is bad, it's not in the voice. So yeah, we do take information from radar and flight plan system when it makes sense. Regarding data link, it's not the case because we haven't been presented with a use case where the two are kind of mixed together enough that it would make sense, but it's a great idea and I take it on. Does it answer your question? Sorry, I don't remember.
In part, thank you. I was more like looking at the implementation steps that you're taking into analyzing. Well, I have an application, for example, the one you said, in which there is a readout of what the controller is saying, climb flight level 330, and there is a readback, the climb flight level 320. And because of that mismatch, you are identifying and highlighting a possibility adherence monitoring issue. Now, I can imagine as well at the same time that equally you have other aspects in which the readback is correct, but the downlink is incorrect, etc., etc. So you have the application that you have, which is voice recognition, but you also have another number of features that exist within the ATM system now that are being used. And the question is what is the process you use to integrate your application within what is already in existence? Because normally it's not a revolution, it's an evolution, and it's a step up of the functionalities. So it's kind of more about the process rather than the technology.
Okay.
Thank you.
Yeah, the process for example, cross-check, which is a safety net, is in fact to first try do validation and experiment on a separate screen, right? So we don't go and integrate it in the main controller HMI directly, because we want to validate, the actual performance of the system. So we kind of try to take it step by step. But I cannot, I try to make sense of a scenario, of a use case where we had to take other environmental data from the context, which is kind of what you ask, and I cannot find a use case directly for that. So yeah, what we do mainly right now is focus on language, because, we could kind of try to bias the model from other things like the previous messages and stuff. And we decided to don't go that route, because we think it's more robust to try to not guess too much from the context, and staying on having the analysis of the message as robust as possible. And we're focused on that right now. Thank you.
Thank you. I think there's a question. Yeah.
Okay, thank you for the presentation. First, I'd like the previous question, even though the readback is correct and the ADS-B is not correct, or vice versa, you want to correct it because there's currently 2 pilots in the plane, and you want to make sure that both of them are on the same page. So even though the system tells you the readback is incorrect, you want to make it correct so that, both of the guys piloting the planes are in the loop. That was just one thing. The second thing with Benjamin, I was wondering, I'm an ETCO as well, and we do have assistants already. We do have planning controllers that prepare the job for us and do the things we don't or we can't do at the minute. My question is how the system is stepping in. Is it going to be an assistant that is going to replace assistants or planning controllers? And if so, is the system able to learn how we work? Because as an ETCO, sometimes the last thing you want is someone to talk to you at some point, because you're so busy that you don't even want an advice. You're just busy working, you're doing your stuff. And is the system able to learn how you work and how I work, or how do you work at a night shift? Because sometimes you're slower. And well, question is the system able to learn how to intervene or sometimes not to intervene?
Who would like to start?
I can just give a bit of information on the thing of kind of adaptive assistance to the air traffic controller. And sorry, I'm going to do some marketing here. This is exactly what the dialogue project that we are in is about, is you take one event, something you're able to analyze from the messages, but depending if you're able to measure, kind of a proxies for the controller workload, the end assistance that you're going to provide is going to be different. And this is what that project is about. It just started, so I don't have an algorithm to give to you today, but it's the point of the project.
Dimitri.
Yeah, thank you for the question. I would like more to reinforce your question, because it's an open, challenging question to me, to our project. We also have the speech recognition use case as one of the digital assistant use cases. So yeah, I'm reinforcing the challenge that the AI system, the assistant, so those who develop it had to carefully consider how it would interact with the user, with the ATCO, with the pilot at different times, at different states. We can reason here. We can think about different modalities of interaction, for example. So if it's not via some natural language or voice, it could be via text or gesture, and the, let's say, the balance and the best modality of, let's say, of the assistant to reach back to the human user has to be adaptive based on the situation, because maybe I'm listening to other messages I'm speaking, so I don't want the assistant to interrupt me and start speaking. So that's an absolutely important consideration in development. From our project, we don't have a definitive answer to that yet. So I just acknowledge at this point your comment. Thank you.
We have time for one final question. Miguel.
Thank you, Barry. I just wanted to express my point of view in this air traffic controller situation discussion that we talked about before, as an air traffic controller as well. And the thing here is that not all the things we do are fun. There are actually a few things that are not fun at all. If you sit in a tower for 2 hours in the delivery position, all you do is just say you're clear to destination, climb 6,000 feet, put it back correct, blah, 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 start up approved. That's not fun. I wouldn't miss it. So if we find a solution that automates those processes or that part of the job, that would be great. That would be absolutely great. I wouldn't miss it a bit. And when we talk about the skilling, one of the things we can probably discuss is whether this solution should be working 24/7 or not. Because if not, we can actually select some periods for ADCOs to train their skills to avoid this de-skilling. And for those who misses this delivery part of the job, they will be happy by practicing it a little bit from time to time. Thank you.
Thanks, Miguel. That's a very good suggestion. I think we need a new project called Eliminating the Boring Stuff. So we're more or less on time. Did you have a quick last? No, okay, it's just waving. So I'd like to thank the speakers very much. Sorry. Quick one, a very quick one.
No, just to respond to our colleague, yes, we are working on removing this kind of tasks. So we have some SESAR project looking on automation using artificial intelligence to be able to remove this kind of repetitive task that we can, with the machine today, do even pushback clearance or clearance delivery, etc. So combining data link, combining artificial intelligence, yes, we are able to do that. Feasibility study, okay. Testing in progress. So in SESAR, we are doing this kind of thing also.
Thanks very much. So I'd like you to join me in thanking the speakers. And back to Paul.
Okay, and then also for myself, thank you all very much. Again, thank you very much for staying on time. Thank you, Barry, for have collected such a good set of speakers all together. I think in one of the next FlyAI Fora, we can certainly discuss a bit further how much fun it is to use AI. For the moment, I think it's actually adding to the fun in our jobs, and that I'll see how that all further develops. So it is now lunchtime, same proceedings as yesterday. Survival of the fittest, go for it. And if not, then there is still the canteen, there's a cafeteria, and there's a small supermarket downstairs. We expect you all back in the room, and we know how fantastically disciplined you are here at 2 o'clock for the last session. Enjoy lunch.
Yes, I can hear you, but I can also hear the music very loud on your side.
Okay, I have to check with my colleagues because I can see that you are talking, but I cannot hear you. So I will see with my colleagues, okay?
Hear me now?
C'est ce que j'ai fait. One, two, 1, 2. Can you hear me? One, two, 1, 2. Test. Can you hear me?
Yes, I can hear you. Can you hear me?
Perfect, I can hear you now. Amazing. Can I ask you to count down from 10 just to check the quality of your sound? Yes, there is some music in the background because of the lunch break. Sorry.
Can you hear me now?
Yes, I can
I
hear
can
you.
hear. Okay.
Good morning. I cannot even say good morning. Hello. How are you?
Well, how about you?
Ça coupe, moi? 1, 2, 1, 2. Can you hear me?
Yes, I can hear you.
Good, perfect. Okay, I can see that the sound is good. Camera also look good. Can you maybe tilt it down a little bit the camera so we can see you a bit more like centered?
I'm trying to. For a second, because it's actually okay. Let's see, because I also have to move from my
little bit
chair.
up.
Okay,
Yeah.
is it okay?
Okay,
I think now it's
sounds
better, and
good.
maybe I'll try to change the background to something more.
Yeah, if you want to put
Uh,
something in the background, it's okay for me.
I normally have my EASA background, but I don't see here. Oh, wait a second. Maybe I can do this, because unfortunately this works only via the browser. So, okay, maybe this will work. No, this is wrong one. Trying one more time.
Non, non, parce qu'elle fait partie d'un panel de discussion. Donc c'est vraiment un test très très léger. Are you trying to set up a virtual background?
Yes. Okay. Well,
Perfect.
I had a 20. I had another one, but let's see if I can. If I manage to find, it's gonna be our 20-year anniversary. Just for some reason, I don't see it right now on my laptop. So
Wait, it's okay. I can see it. So perfect.
Yes.
Nice. Perfect. To me, the sounds look good, and the camera also look good. So for me, the test is concluded now. If okay for you, as I told you in the mailing, you can come back at 1:55 p.m. of course, and you can mute yourself but turn on your camera. That way you're ready when the session starts, right?
Okay. So for now on, I'm turning off the camera and the microphone, and I will connect a few minutes before.
Perfect. You can
start
always
of the
talk to me
session.
via the chat, all right? If you need anything, any assistance, any help,
Okay.
text me in the chat, all right? Thank you very much, Monica, for your
Okay.
time.
Thank you. Bye-bye.
Bye.
Okay. 1400. Time to find your seats for the last time. I hope lunch was good. I saw that not much was left. There was some fruit, some fresh fruit was left, but for the rest, all the other stuff was evaporated. Are we all good to go for the last session? Yeah, we're going to take a slightly different format, hoping also for even further interaction with everybody. So this is really your opportunity to speak up, your suggestions, your concerns, your ideas, your opportunities, etc. And with that, I hand over the floor to Enrico from EDA, who's going to very capably navigate us through the session.
Thank you so much, Paul, and good afternoon, everybody. Enrico Parini from the European Defence Agency. So first of all, thanks everybody for keeping up with us. We are aware of the fact that it's the last panel and it's maybe keeping you from other networking, your flights, going back home. So it's very much appreciated your presence. This is why we have prepared a session that aims at being as really interactive as it can be, as interesting as it can be. But we really do trust on you all to actually make it interactive. So we do look forward to your questions. So before presenting to you the speakers, just a few things from my side, some introductory remarks, as I call it. We can see that artificial intelligence is definitely in the mind and in the hearts of many people today, and for the future will be even more. There will be an increasing usage for several technologies. But I was really curious to see that already in the 1950s, Professor Good, a mathematician, one of the fathers of computing, was already talking about ultra-intelligent machines that can design better machines. So that basically means that machines already back then were foreseen to be able to talk among each other, to actually understand each other, performances and activities and potential. And we were talking about days where basically they were barely able to come up with a computer as such. And then we make a leap forward and we go to a very famous book that I'm sure many of you here have read, Homo Deus, from Yuval Harari. And in that book, he talks about a new concept, a new religion. It's called dataism. So it's basically where men no longer dominate the scene, but they rather worship and almost blindly trust the data. Let's be honest, we're not far from this. This year will be a key year for the next years to come. You may know that 2024, almost 49% of the global population will be headed to the polls. We already saw elections. We will be seeing elections in the European Union in a few weeks. We will be seeing elections in the US, in India. This will definitely affect us. And we know the concern from decision makers and politicians about artificial intelligence, how it can be used and the threat it can actually represent. We have already touched upon the AI Act. That is a very interesting act. I'm not going to go through it again, but just for you to know, there's a very interesting definition of what AI is in that specific act, which is seen as a machine-based system that is designed to operate with varying levels of autonomy that actually may exhibit adaptiveness after deployment according to the levels of the information that is provided, and can then deliver predictions, content, recommendations, and decisions that can actually have an effect both in the physical and in the virtual world. We're not far from it. I think it's a very good definition, so kudos to all the ones that have been involved in it. But what I was also shocked by was the fact that on Friday, I don't know if you heard, but the Prime Minister of Italy is the president this year of the G7 format, the format that gathers the countries and the presidents and prime ministers of the most advanced economies at global level. They have invited for the first time ever a pope for their highest level of meeting. And among all the things to be discussed, they will be talking about artificial intelligence. So this not only shows how timely this conference is, so kudos to EUROCONTROL, and thanks again to all the speakers that have anticipated us and the ones that will be speaking today, but this shows how timely it is. There are a lot of challenges that we have to be addressing. I'm from the European Defence Agency, so of course defense, as we will see, is one of the topics to be addressed. We have cybersecurity, but we also have, for example, the human aspect. And on this specific level, I'm really flattered to be introducing to you Theodor Kiritsis, who will be really giving us a unique point of view. Theodor is working is the president of VATSEP. He's been working for 38 years in the Greek air navigation service provider as an ATSEP. And I really want you all to listen to him, because not only does he have a strong background also in the field of ATM research, looking at the activities in SESAR, but also he will be presenting you new ideas that he called cybersecure AI-assisted ATSEP working position. I really do want everybody to be kept in the loop. He will be addressing resilience, he'll be addressing the human aspect, and of course, if we can also look at cybersecurity items. So, Cesar, the floor is yours, and thank you so much. Thanks, everyone.
Thank you, Enrique, for the kind words. Good afternoon, everybody. I can see that you are awake. I'll try to scare you and wake you up with the elephant in the room. So I am the president of the International Federation of Air Traffic Safety Electronic Associations that incorporates about 75 countries worldwide. That is about 40,000 ATSEP, of which 9,000, about, let's say, around to 10,000 are in Europe. And there is an invested knowledge over the year in those professionals I am proud to represent. So what is the elephant in the room? I scared you off. Did I? No. Okay, it's the maintenance concept. We are embarking in a new situation. We see the goodies that AI brings forward, but how are we going to deal with them? So at the moment, okay, here we go. At the moment, what we have is the ACC room, where air traffic controllers and ATSEP, the air traffic safety electronic professionals, represent the engineers and the technical staff, are sitting close by, sometimes in the same room, sometimes in the room next door. So whenever something comes up, usually the ATCO supervisor, allow me, the air traffic controller supervisor will contact the ATSEP supervisor, and they will discuss what the problem is right there and then. And that model works so far. May I say, with the current state-of-the-art technologies that include legacy systems. Of course, we have degradations, as I mentioned, and failures, technical failures. And now we have a new kid on the block called security, cybersecurity breaches. So as you can see, reading from the presentation, the ATSEP role at the moment, every time we have a disruption, must distinguish whether any problem or degradation identified as a technical failure is a technical failure or it's due to a successful cybersecurity breach. And the ATSEP at the time will have to respond and tactically address the technical issue that might be a cybersecure origin. Now, while this is happening, the ATSEP supervisor will coordinate with the ATCO supervisor locally or remotely in the concept that I will explain in a moment. And of course, the final objective is to reinstate nominal operation for our controllers to work safely and securely on the system. And every degradation is mitigated. Now, we know, I think all of you know of the airspace architecture study that proposes a new future concept that is based on separating, even geographically, the organization of the systems that constitute today's flight data processors and remote virtual towers, or sorry, virtual centers. Now, if you have the sensors located here, the ATSP for the data processing somewhere else, and the virtual center that has delegated part of its duties to another service provider, and the end service provider somewhere else has a problem, how will these people communicate? So we're proposing a concept that is written there in English, in blue colors, but I don't want to take up time. I will explain to you very briefly on the next slide. And that it's talking, next slide, please. Yes, thank you. what you have there is a concept that will collect for every ATSEP working position for the technical supervision, the cyber events, and the CNS and ATM events. It will aggregate these data, and then they will be recorded, and it will aid the decision making based on big data analysis, machine learning, AI supported, in other words, and of course the ATSEP experience. And that will end up in the visualization of the final product. That will alert, hopefully proactively, the ATSEP on duty and will be able to address the cyber event. Now, at the moment, our paradigm is that every ATSEP every system is connected to a console, and the ATSEP will have to stand in front of it in order to address the failure. Now you understand, when we have the systems distributed in different geographical areas, whenever the system gives us a fault, these 3, 2, whatever, entities will have to communicate. This is missing. So our organization of the concept here, which is the ATSEP working position based on artificial intelligence, will allow us to monitor the local system as well as to have a shared picture of the quality status of the different services along the system. Now, in a study that we have proposed to SJU in the past, we proposed also that this ATSEP working position is instantiated for every service provider, for every domain of CNS or ATM. And may I add, since I saw the presentation yesterday of the need of a system, an algorithm to watch the performance of the AI-based application, that should be also included. So what is the maintenance concept we're going to use to address the issues that will come up with AI included in the ATM applications? That's what we're putting forward. And this is the approach we're proposing to be researched. Thank you.
Yeah, thank you so much, Theodore. And as you saw, we're really trying to stimulate everybody. These are new concepts, new ways that we have to consider. Virtual Center is one of the, as we know also from the ATM Master Plan workshop that took place last week, is one of the most preferred solutions actually for the upcoming ATM Master Plan. So it's something that will definitely have to be considered. Now, as I said, we'll be addressing several aspects. Now we'll look at somewhat more of at the research side. We have here with us Anders Settin from the UPC, Universitat Politècnica de Catalunya. He has been working on a project that I'm sure many of you know here in this area, which is the Chorus XUAM. He's actually a recent PhD doctor, so kudos again in 2023. So we're happy to see that you're keeping on working on those activities. And he's actually looking in, among other things, in artificial intelligence, deep reinforcement learning, neural networks, autonomous UAV, a lot of aspects that are dealing with drones. Here, he will be touching upon on counter-drone, and in particular, we'll be addressing 3 different topics. One about deep reinforcement learning, the other one about the ethical aspects of it, and then, since it's coming right up as very often these days, also the security and environmental aspects to it. But of course, do feel free, as I said earlier, to engage afterwards, after Andrew will be speaking, and after you will be hearing everybody from the panel to further exchange also on these topics. Andrew, the floor is yours. Thanks.
Thank you, Enrico. I would like to thank you first, EUROCONTROL and the FlyAI partners to organize such a wonderful event. Just AI for aviation, it's amazing because we had many conferences with AI with many topics, not just for aviation. It's very important. This is the second one. I like to be here, and I'm glad I am here. Thank you very much for that. In UPC, actually, we are working on different research groups. We are in the Icarus research group. and we work with ATM. I am on the drone part, and we work with the, like Enrico said, with the Corsium project and with the use space. And I would like to take you another world, because drones are coming, and I am trying to develop something very interesting with the counter drone systems, mostly with the autonomous AI solution. Why AI is important for me in this case? I want to secure the airports, because you will see more details in the next 2 slides. Because we have many incidents, some of them are reported, some of them are not reported, and I want to secure the airport by AI. There are 3 reasons. One of them is the robust, is more less failure, as I say, and the other one is adaptability. It can adapt to many different changes. And some of you already represented reinforcement learning somehow in your projects. I am very happy to see that also, because it's also very black box, but it can achieve many interesting success stories in this deep reinforcement learning. And the other part is the autonomous part. It can be autonomously navigate, autonomously develop its own decisions. Of course, you can also supervise it, but deep reinforcement learning is part of autonomous, full autonomous system. So I would like to highlight this part. And and so far, we also see many developments on the AI, on the aviation, but in the counter drone systems, we have almost none in this case directly involved in the counter drone systems. And I will talk about this part and the deep reinforcement learning part. And next slide, please. And I prepared 2 slides for the statistical, and I want to highlight this part. In the market, we have many solutions for first detection and the other electronic countermeasures, interceptor drones, and somehow you use the more military options like directed high energy, guns, missiles, munitions, or capturing. And as you see in the first left side in my reference, it's 61% is on the detection part. Maybe you have seen my poster outside in the exhibition area. I focused on the drone detection part as part of the input to my deep reinforcement learning algorithm as an information to increase the training learning process to affect the additional info to my algorithm. So it was interesting. If you have more details, you can contact me later. And in this case, actually, I want to mention here, you see the kinetic attacks. Kinetic means some kind of physical interaction. And here you see laser or using nets to throw very close, getting closer to the target, and use of drones. Use of drones, in my case, I have a single agent powered by deep reinforcement learning, and it is in the 2%. I haven't seen until now in the European part, none of them are doing directly on the deep autonomous AI solution to counter drone systems, because we cannot send a missile in the airport to just terminate one small drone. So we need to do something interesting, more secure for civilians. So it's one of the area. That's why it's important. And another case, actually, some military options may be available. Like I also saw one of them is the microwave. The swarm of drones is also important. It's part of the cybersecurity, and drones are coming. It's basically we need to do something about it. I would like to talk more about it, but I don't want to take so much of time. And if you have more results coming, or you have more ideas, please free to contact me after. I have also a poster here. So glad to be here. Thank you very much for your time. So thank you.
Thank you so much, Ender. Drones are coming. It's something that I think in this meeting room, a lot of people have heard. I don't know if it's a threat, is that the thing, but European Defence Agency, we try to make sure it's both sometimes. But okay, that being said, first of all, I would like to thank the colleagues from EUROCONTROL for allowing us to have Monica, because unfortunately she was not able to be over here in person, but I see you, Monica, and I assume that you can hear us fine as well. I'd like to introduce Monica Adamczyk from ENISA, I guess, even though it was not so much mentioned, honestly, so far. She works in the ENISA, that I guess many of you know, being the cybersecurity agency within the EU. She's a cybersecurity expert, and I have to say that I was very happy to see that not only she focuses on AI, but also on other emerging technologies, among which also satellite, another topic that I'm sure many people in this room have heard of. Before joining ENISA, she worked also in Poland as information security and data protection expert, but she also has a strong experience on different items, just like IT, also including, very interesting, with the International Atomic Energy Agency, and that happens to be in Austria, but she also worked with federal agencies within the US. As you can imagine, she will be focusing on, of course, on the activities on ENISA, on the cybersecurity part when it comes to AI. I hope you can hear us fine, and the floor is yours. Thank you again, Monica, for making it.
Thank you very much, Enrico, for introduction. Thank you very much for inviting me to this conference, and please accept my apologies. Unfortunately, I was prevented from traveling to Brussels for personal reasons. However, it is a pleasure for me to be able to join the event and the panel remotely. As Enrico mentioned, I am employed by ENISA, the European Union Agency for Cybersecurity. For those who are not familiar with our organizations, our mandate is to achieving a high common level of cybersecurity across Europe. Among various activities that we conduct within our organization is we work with various communities to empower them in knowledge and capabilities related to cybersecurity. We support the European Commission and member states in implementing various cybersecurity policies, including, of course, the upcoming EU Act that, among many requirements, of course, has a high level of security, especially for the high-risk systems. ENISA also supports member states and CERT organizations, the national CERTs in operation cooperation. We conduct many cyber exercises that are either on the EU level or we participate in the global cyber exercises, but also we focus on topics, for example, of foresight, knowledge, especially knowledge of various emerging technologies. And ENISA has recognized the need for focusing on artificial intelligence and looking at it from the cybersecurity perspective already 4 years ago. If you go to enisa.europa.eu website and search for artificial intelligence, you can find various publications that we have made available on our website. We address topics such as threat landscape for AI. That means a kind of comprehensive approach to identifying what it's a life cycle, what type of asset would exist that needs to be protected, what is the threat taxonomy. We also provide some guidelines on appropriate cybersecurity controls for machine learning. And also one of the things that has been published last year is something which is called a multi-layer framework for good cybersecurity practices in AI systems that has been actually gathering quite a lot of interest, because that shows that AI needs to be basically secure from a holistic perspective, taking into account not only the AI specific and machine learning specific components, but the entire infrastructure and, of course, both the internal and external context. And of course, in addition to looking at AI from the perspective how this technology, how systems that depends on artificial intelligence needs to be secure, and it also conducts some of the analysis on use of AI in cybersecurity operations. This is mainly something that we focus on by issuing guidelines and recommendations, what type of research, what type of proof of concept should be developed in this area. We also support the European Commission when it comes to development of various standards, and in the context of the upcoming AI Act, we already are collaborating with European standardization organizations on development of relevant cybersecurity standards. And also, in the foreseeable future, we expect to receive a request from the Commission to develop a cybersecurity certification scheme for AI, which will be probably our fourth, if not the fifth certification scheme. The first one, based on the common criteria, has been already not only published, but also adopted by the Commission. We also have right now published proposals for cybersecurity certification scheme for cloud services in 5G, and at least another one that it's been worked on. And I really look forward to participate in the discussion and answer questions, both from the moderator and panelists, as well as from the participants of this conference, on various topics that are related to cybersecurity and AI, such as risk assessment, threat taxonomy, the balance between security, also privacy and functionality, and so on. So not to speak too long and to give other people, other panelists opportunity, thank you very much. And I look forward to the rest of this panel. Thank you.
Thank you so much, Monica, and congrats on the time. I said 20 seconds that was saved by you. Indeed, do not be shy. She may be connected online, but she's absolutely looking forward to your questions. She has presented several inputs that can be of interest to us on the cybersecurity aspect, risk assessment, taxonomy, and privacy. And so I'm sure it will be very interesting, and we do look forward to hearing your views. Then we have Isidoros Monojoudis from European Defence Agency. Funny enough, we never met actually before today, but I guess that's how it is. Actually, we met yesterday. The European Defence Agency is small, but we're very active. So that is most likely the reason. Isidoros is a retired colonel from the Greek Armed Forces, and he's been working for EA for about 2.5 years. He has a long experience when it comes to ICT technologies, about 25 years, as a matter of fact, and also working on cybersecurity and cyber defense. What is really key here is the fact that he will be able to provide you with a lot of information that most likely I'm not aware of. As a matter of fact, he's the one that is dealing the competent department on this topic and working on EDA's action plan on the artificial intelligence. So it will be very interesting. And as I was, to be honest, I was somewhat puzzled by the fact that not much reference to defense was done during these 2 days. Many more things were addressed, but I do look forward to also hearing your views, both from Isidoros and from the audience, about potential information, requests for clarification, and also expectations in terms of artificial intelligence in the field of defense. Thank you so much. Isidoros, the floor is yours.
Thank you all. First of all, congrats to the brave ones that stayed for the very last session of the 2 days conference. And I'm, as already stated, Isidoros Monojoudis, retired colonel, representing EDA, and as a subject matter expert of artificial intelligence for defense in the agency, which is a small agency, as Enrico told, with not more than 200 employees. But we are trying to do a lot to promote research activities for different capability technology domains, including information technologies and, of course, artificial intelligence. So definitely, I will not, let's say, take advantage of promoting defense, but the point here is to maybe identify common aspects and topics between defense and aviation. What is common, in our view, is that both aviation and defense, when it comes to artificial intelligence applications, they have some similar safety critical requirements. So both systems in defense and in aviation, any failure may lead to the loss of human lives. So from that perspective, we need to be very careful when we are talking about AI and how we can trust AI in defense and in aviation. And AI for defense is not something new. It's being something as a technology for more than 30 years. Most likely, the most popular, let's say, topic that you can find on the web is the first DARPA project that is called DART, to support from logistical perspective and using AI agents to predict logistics for transportation. That concludes how far behind AI started to be implemented for defense. Still, after so many years, trust is not there. And this is what we are trying to address. The lack of trust for both commanders and operators to use AI system. Despite the fact that there is a maturity level already established in the market in the private sector, those additional systems that from defense perspective may assist commanders and operators to better decide in the demanding decision-making support process, to enhance the situational awareness, which is also very critical at both strategic and tactical level. It's not there at a level, at a state that can be trusted as such by defense. If we add there the autonomous systems and the level of autonomy that can be introduced and can be used in the military operations, you realize that this level of trust needs to be addressed. I want to mention here to share with you a DoD updated directive from last year that tries to define the level of autonomy. And it stated that autonomous weapon systems will be designed to allow commanders and operators to exercise appropriate levels of human judgment over the use of force, which clearly means that when we want to use force, a person is the one that will make the final decision and not a machine. That is also aligned with the human AI teaming approach, even if it's not a preferable term. It is widely used also in US. And to link that with aviation, two ongoing projects, big projects in US are about swarming and teaming of a jet pilot with a group of autonomous fighter jets to work together in collaboration and cooperation structure. But again, what is not extensively researched is the point of failure. I've heard before a very good statement of what if the human pilot fails? What will happen to the autonomous drones? Will anyone be designed to take over control of the operations? Will the mission critical level will be higher than the safety critical? Those are questions and topics that need to be addressed from ethical perspective in defense. Concluding of what EDA is doing and to promote a little bit our work is we have under implementation an action plan for defense with two key pillars. One is the data space and data pool. I have read that, and I know that EUROCONTROL owns a repository to share data sets for applications and for training AI systems mainly also. And so a defense data space is a concept that needs to be researched for sharing valid data for training AI algorithms for defense. The other pillar is the trustworthiness for defense in an effort to identify the verification validation standards to better test and evaluate the AI systems, since whatever is being tested on the public and private sector is not equally addressed or can be implemented in the defense domain. The special military conditions, what we call the defense denied communication and the limited environment, can make the AI tools, especially at the technical level, at the tactical level on the field, to have unknown and unpredicting results. Data and information exchange and communication is not confirmed, cannot be guaranteed in this demanding and very limited military environment. So additional testing needs to be done in order to make sure that systems will work properly and as designed. And that's conclude my first intervention. Thank you.
Actually, 6 minutes. So it's like every meeting in EDA. Yeah, in EDA, if you get there at 2:01, you're out. So it's a bit different compared to the usual Teams meeting. Then last but not least, we have Bakhtiar. Thank you so much for being here. Actually, the only one from EUROCONTROL. So thank you for also being one of those that is actually hosting us. With a lot of experience when it comes to cybersecurity. It was already mentioned by Monica about CERT, that is where you work in the EATM. CERT, you also have been very involved, for example, on cloud and network security. We talked about also Security Operations Center. You have worked with several also defense and contracting agencies. I have to say, when you presented me your bio, you gave me acronyms I was not aware of. So that shows absolutely a bit the fact that I definitely need to improve my knowledge on the sector. But in the meantime, the fact that you have also been involved in drafting new standards, new activities, and also papers when it comes to specifically cybersecurity aspects. It will be very interesting to have your views, not only because, cybersecurity threats are all over, but also because, you're hosting us. So let's see how you're actually, guys, dealing with that. So thank you so much. Bakhtiar, the floor is yours. Thanks.
Hello, everyone. I'm glad I helped to learn new terms in cybersecurity. I'm Bakhtiar Mustafa. I'm a member of EATM CERT. I have around 25 years of experience in cybersecurity. Last 5 years, it is inside the EATM CERT. EATM CERT is a department inside the EUROCONTROL that deals mainly with the cybersecurity and provides a number of cybersecurity services to both internal teams and external aviation stakeholders. And by aviation stakeholders, I mean air navigation service providers, civil aviation authorities, airlines, airports, and manufacturers. What we try to do is to keep them secure, cyber secure, as much as possible. And for that purpose, we provide them as a number of services, let's say. I can divide that services in 4 different categories. The first category is security assessment services. In that category, we provide a penetration test, which is the most famous service that we provide. It is like behaving like an ethical hacker, using tools and techniques like hackers to secure the systems, to detect the vulnerabilities and report them and alert our stakeholders to patch them before actual hackers attack them. Another service in that category is security assessment. We analyze the infrastructure of stakeholders and provide recommendations for a better hardening. We also provide red teaming and cybersecurity exercises, and more specific services like DDoS testing, like emulating a DDoS traffic to see if the infrastructure of stakeholders is able to handle that much traffic, and so-called phishing exercises to simulate malicious emails to see how the people are responding to these attacks. This is the first category. The second category is incident response and digital forensics. In that area, we provide services like incident response coordination. Whenever a cyber attack occurs, if any of our stakeholders requires assistance, we can provide them remotely mainly. And if they need, we can analyze digital artifacts and provide them with signatures. The third category is cyber threat intelligence services. And for that purpose, we constantly analyze cyberspace for new threats, new leaks, new attacks, and try to alert our stakeholders. For example, we continuously monitor dark web forums for new data leaks, and whenever new data leaks or new incident occur, we automatically detect it and try to alert our stakeholders. We also have an infrastructure for that that's called MISP. It stands for Malware Information Sharing Platform, which tries to distribute that information as much as possible to stakeholders.
And the last category is alerts and warnings. Whenever we detect a critical vulnerability or critical attack, we try to alert our stakeholders about the attack and how to prevent it and how to deal with it. So, and the most interesting part of our services, they are free of charge to our stakeholders, so everyone can benefit from them. So this is briefly EATM CERT and what we do at the EATM CERT. And how do we see AI and machine learning it's a new trend of technology first, and I can divide our view to AI in 3 different categories. First is opportunities. Of course, through yesterday and today, we all talked about the opportunities and how AI is enabling and supporting humans, increase productivity, and how it is used to do more challenging tasks. And we also use it inside the EATM CERT in some projects. We will talk about them later. It also provides us with the dedicated knowledge databases and helps us to automate boring and repetitive tasks. These are the opportunities. But also we should be aware that there are some challenges and risks in using AI. And I think it is not talked enough when we talk about AI. For example, in challenges, especially in cybersecurity and cybersecurity inside the aviation, the most challenging part, if you want to develop a project, is lack of data. Because as you know, people are not very happy to share their vulnerabilities with each other and with other partners. And that's why we have a really big challenges finding a good data to train and produce our projects. Another challenge is accessing the data or sharing the data. Even if stakeholders are having the data, they are not happy and they are hesitating to share the data. This is another challenge. And if somehow we have access to data, and the challenge is quality of the data and using and how usable it is inside the projects. When we talk about the risks, I can talk all day about the risks of AI, but we have a limited time, unfortunately. But I just want to divide it in 2 different categories. First is AI-specific risks, and the second one is generic risks that are applied to AI projects. For AI-specific risks, I can quickly mention about the specific attacks to AIs like data poisoning, like prompt injection, etc. And for generic risks, I'm short of time, but maybe we can talk in later. But just to keep in mind that this is a new technology, and like every new technology, we should secure it and we should harden it. And we should spend more time in thinking about how we securely use it. I think this is enough for introduction. Thank you.
Perfect. Thank you. Thank you so much, Bakhtiar, for your introductory remarks as well. So as I said at the beginning, really the floor is yours now. We have given you a few inputs from training, resilience, cybersecurity, defense, risk assessments, ethical impacts, human impacts, looking at taxonomy, looking at the upcoming challenges. So if I'm wondering, I'm looking at internally in the room, if anybody has any questions. Yes, please.
Thank you. First of all, thank you again to everybody for the great session. The question is about the moral aspect of having the human taking the last decision in the context of an attack or no attack. Let's imagine you have a context where you have 10 potential targets. AI decides to eliminate 5 because they are not relevant for whatever reasons, remains 2 available to, let's imagine in that case, a pilot. And the pilot has to decide which one of the 2 he wants to strike. Can we really say that the pilot has the last decision just because he has 2 out of 10? what happens if the AI eliminates 8, let's say, correct targets and just provides 2 not so good targets? Would that still be a human choice?
I guess this is for me, right? Well, as stated, the main priority, the top priority is for such decisions to keep human in the loop and on the loop. So definitely the last decision will be taken by the person, by the pilot or the commander or the operator that is using the AI system, because he's the one that will have the best picture and insight of the conditions, including what AI can support, can propose. So indeed, the point is that human will be the last person. Though I can say that there are use cases where AI fully automates this system can make a decision. Let's say a popular use case is how to counter the high velocity missiles. For such a threat, there is not enough time for the human to decide between detection and neutralization of such a threat. So for such use cases, a fully automated AI system can really take the decision to neutralize the threat. But this is only in that context. And again, the human will be the one that will push the button to engage this AI-supported counter high-velocity missile system to take down such a threat.
Is that okay? You're satisfied with the answer?
No, it's okay. Thank you.
Of course. Thanks. No, so I have to say, of course, also complementing what was said today, of course, now we're talking about the question was specifically on the defense side, but today the colleague from IFATCA, highlighted the fact that we're not competing with artificial intelligence or with the technology, we're rather complementing. We have to make sure, if we look, for example, at air traffic management related operations and activities, that we can enhance the service, the performance, the productivity, and whatnot. So, of course, this is just a perfect example that can be applied to defense, for example. I don't know if anybody else from the panel wants to get back on this issue. Of course, it's a bit more defense related, but no? Okay. Okay, I also see Monica not nodding. Anybody else? Any question? Yes, please, Teddy from CANSO.
Thank you, Enrico. This is Teddy Minga from CANSO, and I have a question. From a cybersecurity perspective, what are the challenges that we see in let's say, with the growing numbers of AI solutions, AI research, AI projects, and its regulation?
Thanks. It's a broad yet very interesting solution. Of course, I'm lucky enough to have a panel that maybe all of them can actually contribute to your question. And I think also Monica might be interested in it. So if you want, Monica, as you're online, if you don't mind, you may go ahead. Thanks.
Okay, thank you. Yes, so challenges are many, I would say, for various reasons. So first of all, we have to remember that AI is just one of the technologies, one of the digital technologies. And same way as traditional ICT systems, where these are operational or typical, IT, it needs to have an effective protection. And this protection has to exist on the whole infrastructure across all the layers, taking into account not only AI and machine learning specific functionality, specific threats such as, for example, data poisoning, or for example, model evasion, or another typical machine learning threat is called Oracle, which involves manipulating the input of the algorithm and then watching the outputs, but also has to take into account all the support infrastructure. So if you think that you can ignore things like access control, like appropriate policies and procedures, that you can ignore protection against not only the malicious incident, but also human error, you can't do this. You have to take into account everything. And unfortunately, one of the issues that I've seen that has been ongoing is that while AI is, I mean, on one hand, we still call AI as emerging technology, and of course, certain techniques and approaches get developed. But at the same time, I still see the old age problem that we first come with innovation and then we think about how to apply security. So concept of security by design, concept of security by default, it still gets ignored very often. I recently had a presentation on cybersecurity and AI at one of the conferences, and not only 10 minutes has passed after my presentation, somebody stopped me and said, you know, I work for a small startup, we develop some AI solutions. Can you really tell me if the cost of applying AI after the implementation is higher than considering security from the beginning? So all these challenges exist and they are not much different from cybersecurity challenges that exist in the concept of traditional technology. Another challenge that also exists is that the risk management, risk assessment that needs to be conducted over the entire life cycle of an AI system has to take into account not only the changes in the stages, but also the fact that very often during the operational phase of a system, that system can self-change, meaning that let's say if we even do the regular risk assessment to see whether applied security measures are still applicable, they still provide effective protection, we also have to be prepared for a situation where that system changes without, let's say, a managed change control. And this is one of the more unique challenges that exist in the AI systems. So, and then of course, you know, over-reliance on outputs of AI. So while we're talking about cybersecurity of AI, we have to remember that possible impacts and negative consequences when a system is compromised could be very various, could be also not just technical effects, but also they could have impact on individuals and society as a whole and on various sectors. So this is from me, and I hope that the rest of the panelists share also their perspective on this aspect. Thank you.
No, thank you so much, Monica. Indeed, it was quite a comprehensive response. I hope for this part, CANSO is satisfied. But as I said, I think the whole panel can basically address it. So, Bakhtar, the floor is yours. Thanks.
Thanks for the question. And I want to extend the views of Monica. Thanks. And I was going to say almost the same arguments. Just to point out that there are generic aspects that need to keep in mind, like every new emerging technology, but also there are some AI specific risks and concerns. For example, one of the major things that we started to see is data leaks and the leak of intellectual property. When you start using a public AI service like OpenAI Cloud or some other service, and if you upload any sensitive data or any intellectual property like source code of your proprietary software, it is impossible to unlearn it. Once it is uploaded to a public model, it learns from your data, from your source code, and it's not possible to unlearn it. It's not possible to delete it. This is one of the major things that we started to see, and there are already some incidents. Some companies, some software developers inside the company uploaded the proprietary software to enhance and find the bugs, but unfortunately, it caused to leak the proprietary information. This is one of the important things.
Indeed, a reminder also for the companies to make guidelines about it. And we all use Copilot and other tools to maybe have a summary of some documents, but it may not be so efficient in the long run. Tudor, I think you wanted to take the floor. Thanks.
Thank you for the question. I'll take a different approach. Speaking on the human side, we always address issues on the basis of human people, procedure, and systems or equipment. So whatever the threat is out there, by technology, we have to improve all three of them. The people with better training and better hiring profiles, because the demand now, I have a slide later on that, the demand for more qualified people with scientific background to serve in the new AI-based systems, although this might be farther in the future, will have to be reconsidered. And these people will have to be motivated and attracted in our domain. When it comes to procedures, procedures have to be adaptable and revisited continuously. And we have to have, I think, management in ANSPs to begin with, must have a buy-in process actively at all times, because whatever you learn from the ATCO on the controller working position or the ATSEP on the ATSEP working position, you should feed into the organization and streamline it. And equipment, of course, I gave you an example of a cyber secure AI-based ATSEP working position this morning, that although we are embarking on such a paradigm shift in terms of technology, it hasn't been researched yet. And I guess that will be exploratory research to begin with. So what we're building, to use an example, if you allow me, this morning about the nuclear stations, we're building a nuclear station, but without technical supervision, formalized, defined, interoperable, whatever. And when it comes to procedures and the way we work, we also have to look into the regulation. And we saw there is a lot of excellent work ongoing in EASA at the moment with the various regulation. But may I remind you to the extent that I know, my knowledge is current, at the moment we're producing software, but there is no regulation like 482 of 2007 that requested software safety assurance. So what is happening here? If this is, if I'm not making a mistake, that is, and on top of that, may I sort of also raise a flag here and say that safety management systems are not required to be implemented by technical services, CNS providers. So if we're talking about, according to the EASA regulation, of high-risk systems that have to be classified somehow, how are we going to supervise the safety and assure the safety in these systems when they are not included in the regulation? So I think this is a top-down approach, if you allow me. Thank you.
Thank you so much, Tudor, for stepping in. That was very interesting. Also, having a look at all the components of the field. I don't know if Isidoros also wants to step in on the specific question from CANSO.
No, I think it has been covered extensively. What I would like to stress out, to highlight, is also the threat to data that are being used. It has been also stated, but this is very critical in how we use and how we need to secure the AI systems and AI applications as a major challenge in the future. And now.
Thank you so much. Thanks, everybody. And they're not on this specific topic. I'm sure you'll receive something. I don't know if anybody else would like to take the floor. Yes, please.
I just wanted to add something about the safety management system, which was just mentioned. Actually, a lot of the conversation we just had this afternoon overlap with another interest in aviation, which is quite recent, which is the passing of Part IS, so about information security. And indeed, the biggest part of Part IS mandates is actually the implementation of an ISMS, so a safety management system dedicated to information security. And I think the conversation today on AI ties in very much with that. So raising awareness in the whole of aviation beyond cybersecurity. If you operate an aircraft, if you are involved in operations, you will soon need to implement and look at cybersecurity in a different way. So I think it's very relevant.
Indeed, thank you so much for your remark. No, I mean, would like to thank you. Indeed, that was an interesting part. Part IS indeed is a very sensitive topic that we have to keep an eye on. And kudos to EASA, honestly, for being able to do so. And of course, I'm sure that many of you in the room might have contributed to drafting the part. So congrats to those that were actually involved. I don't know if anybody else has any question.
Yeah, I was actually going to ask a very similar question or comment, but I was just pointing out that additionally, the first usable guidance from EASA also requires that we meet cybersecurity objectives. And with those, the approach is to apply AMC 2042 that we're using, where we're using EUROCAE's DO, well, there's 3 of them. I was wondering if any of the panel members would like to comment on whether these standards are already good enough for AI certification, or whether they have some soft spots or room for improvement.
Are the standards that we have already enough when it comes to the AI certification? Isidoros.
If I may start with a comment, I don't know if they're enough. I know that for sure that we are in the phase of developing standards, and it is part of the work we are doing in the European Defence Agency for defense, but mainly to identify, to recognize what standards are already being developed, and can be tailored for defense. A point that I would like to share of how difficult is this to put it on the, let's say, on a ground that it will be sufficient, is that NATO DARP, the Data for AI Research Board, was supposed to release last November the first standard for responsible use of AI, and this has been postponed for 1 year, for next November of 2024, highlighting the fact that it is still a work in progress. It is still a work that needs additional input in terms of how we can standardize responsible use of AI, if that can be used as an indication of the significant effort that needs to be done towards that direction. It's a long way still to be done.
For sure, a long way indeed. Theodore, please.
Thank you. I will ask for your patience, and if you allow me, I will make reference to Regulation 203 with regards to, I think it's cybersecurity produced. And I remember, because we were working on the future role of ATCOS and ATSEP and other frontline personnel in the European Group of Human Dimension. And I remember there reading the Regulation 203, which puts down an IT perspective concept for cybersecurity. And as an engineer, I was looking for the technical solutions, that should be mentioned in the regulation. And I apologize if I'm making a mistake, but as far as I remember, it says at one point that the organization has to have the necessary tools to address the problem. Do I remember well? Yeah, but what are these tools? These tools have to be developed and follow certain criteria, etc., etc. And if I am allowed to add something on the safety perspective with regard to AI-based systems, I was asking my colleagues at the break. So let's say that we have an incident or an accident, God forbid, and we have to do now to follow a different procedure. So there has to be an incident or accident investigation, but the system continues learning. Okay, so should there be a procedure that says, now since we have something new, a new kid of the block, let's take a snapshot of the current maturity or evolution of the system, because if the system keeps learning and you judge the controller or the pilot who made a mistake, on erroneous information, let's say, or a human error, then you don't have the same basis for the judgment. And a colleague of mine, Mr. Simiakis, mentioned that to me on the phone. He's a regulatory expert from EASA. He said that whenever you do the analysis of an incident or an accident, a safety analysis, that is, then you come to a result and a lesson learned, and you disseminate the lesson, and it goes around and people learn. However, this lesson is valid only for the current state of evolution of the system. So a lot of things have to be revisited, I think, on their way. Thank you.
No, thank you. Indeed. I mean, also Monica was talking about, the fact that compared to the other threats that we know, the difference between the AI is the fact that it's actually evolving. And we, as I talked at the beginning already in the 1950s, we were talking about machines that can actually enhance themselves. I don't know if, Monica, I know it's somewhat quite aviation intense on this aspect. I don't know if you also feel like complementing the information that have been provided by the other panelists on the question.
Yes, of course. So first of all, the standards that will be applicable, especially for the cybersecurity of AI, are being developed. As I mentioned, first of all, in the context of compliance with the AI Act, the Commission has issued standardization requests to Senelec that is supposed to work together with ETSI to develop those standards. ENISA also supports the European standardization organizations in development of the standards. Of course, we focus only on the cybersecurity aspect, but one of the standards that it's either was published already or is being just developed from ISO IEC standard 42000, which is basically the management system for AI. I believe one of another standards which may not be cybersecurity specific is ISO 23053, which is framework for using machine learning, and so on. To the best of my knowledge, right now, at least on the EU level, there's no certification for AI because, as I mentioned, for such certification to exist, first of all, the Commission needs to issue a request to ENISA to develop a candidate certification scheme. And we do actually right now conduct a feasibility study to evaluate, first of all, existing certification schemes that have been already developed under a Cybersecurity Act, which basically it's a mandate of ENISA, whether some of those certification schemes could be also applicable to AI systems. And the good news is that it will be possible to reuse many aspects of the certification schemes in future certification of AI. Secondly, we also conducted an, actually this was already published last year, a feasibility study to assess the current state of existing standards that are available. Some of them are published by ISO, but we also cannot forget about, for example, NIST AI risk framework that is considered right now probably the most mature risk assessment framework for AI systems. So all this work has to be taken into account. And since there has been already also a discussion about intersection of safety and security, it is of course very important in different sectors. I heard one of the panelists mentions nuclear sector, of which of course I have some knowledge and experience because, as Enrico has introduced me, I used to work for an UN organization, International Atomic Energy Agency, and of course, given the potential devastating consequences of any incident, whether this could be a physical safety or security, or digital safety or security incident in nuclear power plants, or I'm sure it's very similar also in the aviation sector, in which I also have a little bit of experience because one of the federal agencies I worked for in the US was Federal Aviation Administration. So obviously the need to remember that safety and security go hand in hand, and very often the safety standards and safety policies and regulations also serve security because they minimize the risk of a compromise. At the same time, security regulations, and one of the security regulations, cybersecurity regulations, which also applies to the aviation sector, is, for example, NIST directive. They also assist and support in ensuring maintenance of safety in every critical sector. So things kind of depend on each other, and also have to take into account not only the legal obligations, which, you know, unfortunately, in some cases, they can be, you know, you can meet the legal obligation and still not have effectively a secure system or miss on some safety features. I mean, we hear recently about major issues with, for example, Boeing in the US with the planes that have, you know, various failures. You know, if you check vulnerability databases, you do see occasionally, you know, cybersecurity incident. But effectively, all of them need to be applied not only because a law requires this, but because this is the right way to implement and then, of course, operate those systems. Thank you.
No, thank you for chipping in. Indeed, a very thorough consideration from your side, and of course, a lot of things coming up. And of course, you also mentioned some of the regulation where indeed we must indeed consider in the aviation field, such as NIS directive. Very interesting, and of course, in continuous evolution. But I see Ender also wants to chip in on that matter. Please.
Yeah, thank you, Enrico. Yeah. I want to mention, actually, I am not a regulation person, but I am a researcher and I spent few years to understand what deep reinforcement learning agent is doing, actually. It's one of the interesting part. We need to investigate more on explainable AI methods to understand why this AI agent is doing this decision. So it's, as you know, the reinforcement learning methods mostly based on trial and error experiences. You can also implement your expert demonstrations and you continue from transferring your knowledge and you try learning on this training. But if we know what agent is going to do this mistake, we can understand better the AI methods, what's going to happen in the next stage. I'm not sure we are going to supervise humans by AI, but we need to know why AI is doing these mistakes. So if we know it, probably we are going to make better solutions for certification process. So it's one of the important parts. So I have some experiences in the simulation watching the AI agent, the actions, what he's doing. Some actions I cannot explain is successful to terminate the target, but some of the targets and doing random decisions, random behavior. So it's very confusing in some part of view in the AI, but in the certification phase, we need to know the explainable AI methods more and more, and maybe new methods coming. Thank you.
No, thank you for chipping in. Indeed, that is the purpose. You know, we always have to enhance and understand why some things are not working or behaving like they're supposed to, and how we intend them. You wanted to take the floor, indeed. Apologies, but it was a very interesting exchange. So I hope you enjoyed it.
Don't worry. No. It's a little bit the continuation. My question is a little bit the continuation of the theme, I think. So, and it's mostly directed at Theodore, and I want to look at it a little bit more from an operational perspective. So, you talked about implementing systems in your concept for dealing with unexpected events, and especially if you're in the transition phase of the implementation. I'm just curious how you would deal with unexpected events in that context, because it seems like a complicated thing. So
that's for you, Theodore. Go for it.
Thank you. Very tough question, actually. But I think that we don't know the future. And as we said earlier, as I said, if you prepare for the future, you'll be able to anticipate the problems. I think that this is where the goodies of AI can come in and help. Because when you have the distributed system I mentioned earlier, that is with an ANSP that is using an ADSP, and let's say a virtual center of ATS provision, uses an ADSP which is in another country, and they're delegating part of their airspace to another provider, which is again in another country. We have a fragmentation here that needs coordination. This is totally a new system. The human cannot deal with it, because whenever the problem comes up, let's say in the delegated airspace, and they call you, and it's a technical issue, you cannot locate it. So I think that if you build those agents local agents, the ATSEP working position, and that is also supervising the controller working position, then the ATSEP on this side can inform the ATCO supervisor on the other side of what they are seeing. Now, if there is communication, then they can have a shared total situation, total system, technical system situational awareness that we don't have today.
You're satisfied with the answer?
It's a good answer, thank you.
Well done, Theodore. Want to take the floor, please?
Yeah, just to add other information, there is also other way to prove that AI system can give a good result is the conjecture principle. It can be used as a mathematical conjecture that you have a problem and you want to find a solution that could mostly statistically go to one direction is about, in mathematical aspect, a pre-shift topos. For example, that you have a point of view, a perspective that could give a big amount of solution. You can classify a problem. You can classify every books, for example, in a library to a category. So that give a good information for identify solution. Thank you.
No, thank you. Of course, it's interesting. Then, of course, we go back to the matter of accessing the data, having all the right data, the quality of the data, who can be trusted with the access to the data and so forth. But of course, it's one of the, I believe it's one of the bases to really build up a trustworthy AI system. I don't know if any of the panelists would like to contribute or chip in on the matter. Also looking at Monica. No? Okay.
I think that there has been already discussed a lot, but maybe the thing that I would just offer us as additional things that, that's why it is very important for AI systems to be not only secure, but also have attributes of trustworthiness, of transparency, of explainability, because the more we can know about the system, the more we can understand about functionality, the more we can take into account and rely on the outputs of such systems. So this is, of course, important. And I know that one of the challenges that at least existed up until recently, and I think is still not fully resolved, is that how to measure those, how to decide that something is trustworthy, because sometimes it is a very qualitative attribute, and at the same time, perhaps it is possible to calculate it mathematically, although my background is not mathematics, so I wouldn't certainly attempt to do anything about this. Same with the transparency or explainability. That's why, responsible AI is not only a secure AI, but also AI that has many other characteristics that allow us to not only benefit from whatever objective functionality or intended functionality of the system is, but also to make sure that there is no bias built in, there is human oversight, and then we can trust the system, of course, within the reason, because ultimately, at least in my personal opinion, we should be the final, we people should be the final, judges, whether something should be done or not. Of course, it doesn't mean that we control every single tiny stage of the algorithm or the process, but there has to be basically the human oversight that is absolutely essential. Thank you.
Thank you so much indeed. I very much like the responsible AI, not only secure AI, and of course the fact that, as we said, very in numerous occasions, also earlier, about the fact that anyway the human is there, and that has to be fully considered, and most likely is the one calling the shots at the end of the day. I believe the gentleman at the end of the room also wanted to ask a question.
Thank you, Mr. Chairman. Good evening, citizens. Of course, it's a very good discussion. I'm glad that there are so many experts here, because we don't mention at all the automaton, which is a mixture of AI and robotics, because AI is nothing without the robots, without the smart machinery. And as the gentleman mentioned about the human in the military thing, because you say that at the end of the day, the human will take the decision. Yes, for the current knowledge we have, which is very primitive, yes, it's like that. But if we put the generative AI, which is developed in very fast ways and rhythms, so that we can speak maybe later on for the artificial curiosity, artificial conscious. In the Greek language, conscious means plus news, plus data. That means that maybe, we don't know this yet, but we are the creators and we imitate ourselves like somebody else did for us. So maybe we'll give artificial conscious to these machines. So that's why 3,000 scientists all around the world, we signed that we have to take care about our movements and we have to slow down the procedures for AI. And maybe we can work on specific experimentation level, which will narrow through the population, the expansion of this technology, but will augment the research and the knowledge we'll have. As a second, because the lady spoke about the systems change, the regulations, they are nothing. Okay, we'll put the regulations everywhere, but sometimes the system is over the regulations. Depends the knowledge it gets, depends on the curiosity of the human. Because if we don't have the curiosity, we are bored and we leave the machine to work for us. This is going to happen at the end of the day. But as the energy is a problem, because the lady spoke for the consumption, that's why I participate lately to the community steering here in Europe of the molten nuclear reactors communities. The regulation there, Mr. Kiritsis is right, is not ready because the materials we use, they're under discussion for the optimization of the systems. So the energy, if we, at the end of the day, these administrations, they are getting the nuclear energy. One reason is because they want to feed the artificial monster, as yesterday was explained, was given by a colleague, so that this has the capacity to act on behalf of us in other things. And on the military sector, we know this architecture of the internet. At the end of the day, we have two end sides for the loop, the West Coast and the East Coast. Over there are the data centers, the endpoints. So if the hacker, a human or a machine, enter there, it can get any information from the military concept if we don't have the better knowledge of the regulatory and other things. That's why I'm speaking for the CNET, the European Internet, which will create two different endpoints and loops to the loop of the European citizens. Thank you very much.
Thank you indeed. I think you might have anticipated some of the items also yesterday with your question about the independence on this topic. Given the impact, I don't know if maybe Isidoros and Monica might be wanting to step in. Isidoros?
Yeah, from a defense point of view perspective, again, if I can use a term, one of our concerns is to stop Skynet from being let's say, in the future. So that means that always, and technically speaking, as far as I can tell, there are the right buttons to deactivate an AI system, and we can still be on the loop and have the last decision to be made. Of course, the level of autonomy is something that is being evolved, and we cannot predict the future. That's why we're trying here not to over-regulate, let's say, the area, and but to give the right requirements and implementation solutions of how to develop trusted AI systems for the future. And of course, for the defense, depending and relying on those specific conditions about defense. Now, in terms of data centers and East and West Coast, this is a huge discussion, okay? Again, we cannot say, we cannot guarantee when and how a hacker can do such an attack. Even if it can be an insider, but in that perspective, makes it even more difficult. But yeah, as an overall, conclusion, indeed, to trust AI takes time. It is a long way, but definitely my perception is and my feeling that, as already stated, given the high concerns, human will be the last point where the decision will be made, especially when we're talking about human lives and critical systems. Thank you.
Okay, thank you for nodding. I can see that the answer was indeed quite satisfactory. I don't know if Monica, you also want to chip in, given the reference it was done to the regulatory framework, or?
Yes, so as I have already actually mentioned this, that no matter how many laws we will enable, no matter how many legal obligations we will put on the operators and providers of AI services or any other technology, it doesn't matter if it's an AI. We used to talk about the start of internet 30 years ago, cloud services. It's never going to be sufficient, meaning that, first of all, this has to be a very good understanding, awareness that things like security, responsible development of systems, it's something that has to come instinctively. That's why, development of security awareness, development of cross sector competencies, especially in the AI technology, it's actually very important. This is actually one of the areas that people who are data scientists, who are analysts, they also need to understand why, let's say we that are being considered to be, those who try to prevent them from doing, fun things and interesting experimental, why we keep talking that this has to be done in secure way. And maybe except for extremely well controlled laboratory environment, it really needs to apply the security measures, at least the basic cybersecurity hygiene that needs to be available, and those data scientists need to understand reasons and arguments of the cybersecurity experts. On the other hand, of course, it's also very important that those whose job is to defend systems, defend digital systems, defend ICT, defend the technology against various attacks that could be either of pure cyber nature or of hybrid type. Sometimes it's a combination of physical and cybersecurity. It's also important, especially in the AI technology, for the cybersecurity expert to also understand at least the basic concept of AI, to have this common language. And then on top of this, what I also mentioned in the beginning is that AI never exists in a vacuum. It's not that just, I have, something that's pure AI and nothing else. It is a part of large infrastructure. That's why it is so important to have this defense in depth approach. That's why it is important to have kind of multi-layer. So a single point of failure is not being developed. So maybe if something that runs in experimental mode, and it's very difficult perhaps, to come with a specific security measure or control that would be AI specific, that component or that algorithm or that subsystem, it's being protected by various security measures, various security defenses that are either implemented on supporting infrastructure. They could be also implemented by having physical security, although we do probably all of us heard of a famous Stuxnet, accident that, of course, it was, air gapped, and there was physical security, and still, of course, it is actually a nuclear IoT incident, so it has been still compromised by basically plugging in a USB drive. But the more of these multiple security measures, including organizational and human security measures, are implemented, the better chance we have to actually prevent a cyber incident, the better chance we have to identify a problem and respond to this as quickly as possible. But at the same time, we have to remember there's no 100% security, there's no perfect security. It is always an ongoing chase between the good and the bad guys. It's always an ongoing chase between those that try to use any technology, including AI, for nefarious purposes, for compromising systems, for causing, harm, and those of us who try to develop and use those systems for good and very, very, humanitarian reasons and for business purpose, and of those who are trying to defend those systems. So we just basically have to remember that. But it's I would say it's the same. Very simple things. You can always, look up on a street when you try to cross a street, and make sure that you, of course, that don't get hit by a car. And still, there is a chance that you get hit by a car. So we need just to look forward. We need to have trust, but trust with a certain level of skepticism, to make sure that we will have a culture of trustworthy, of responsible, and of transparent AI technology. Thank you.
Thank you indeed, Monica, for the very comprehensive feedback, honestly. The fact that we're talking about AI also as part of infrastructure in this place where, network manager, infrastructure manager, it's a very interesting, of course, more when it comes to the activities and what we have been discussing today. So if I look at the clock, we're perfectly on time. But Theodore might have one thing that he still wishes to address. He will take just a couple of minutes, but it was really important. Well, first of all, I have to just congratulate everybody. You've been so active that we did not even have to address the questions for the panel, from the panel. So kudos to that. Very happy to see the involvement from that side, and it's so. It has been so interactive that Theodore was not able actually to address all the questions. So he will be addressing one specific item that is very dear to him and to IFATSEA. So please, you'll have the floor for that. And then we conclude. Thanks.
Thank you very much for the privilege. Also, it's again on the human side, and it's implicit. It has to do with training requirements. And specifically, I can speak about the impact of AI and cybersecurity requirements on the ACEP training, and tracing the training, which will be basic training, specialization training, qualification training, and of course on the job on issues that relate to cyber attack and cyber terrorism. At the moment, the competency document on the ACEP in ICAO, it's been revised. It was decided last year with regard to the ACEP cybersecurity tasks. But also now here, since AI is coming into the scene, there have to be some similar AI basics for system acceptance and maintenance. I forgot to mention that earlier for Benjamin, but whenever we will be accepting in the years to come in the transition time, systems that will be involving AI, will have to have the tools, understanding, and a basic knowledge in order to accept them, to do the provisional and final acceptance tests. Now, with regard now to the new architecture that is coming into the scene through the airspace architecture study, we'll have a distributed system which will have to deal with potentially with the cascade failures. So the ACEP, and if you allow me, Benjamin, the ATCOs will have to sort of train on simulators for this distributed environment. I haven't seen that being researched yet, nor have I spotted it in the SRIA. So what we're proposing on behalf of IFATSEA is to develop ACEP working position simulators and an environment, of course, based on digital twins. And of course, as I said, that will include a cross-country coordination element as well. Now, when it comes to the ACEP working position, as I've said many times, we'll need to have the notion of the digital assistant mentioned earlier, helping the ACEP on job to identify proactively that something has changed in the system. And of course, there we'll have to talk about interdependencies, because when it comes to networks and you have something changing, I don't know. I have no idea. This has to be researched. However, now we're talking about this collaboration on the basis of technical information exchange and coordination needed. The language issue comes up now for ATSEP. That was a requirement for the ATCOs in the past for obvious reasons, but now through this concept, we'll have to have them be able to be proficient in communicating beyond the borders. What is really, and I'm raising a flag on this, the industry consultation body has raised it, EUROCONTROL has raised it, and that is the lack of ATSEP. We don't have ATSEP. So there has to be a career development, and I don't know, the experts have to look into it to attract new engineers, new specialists into the domain. So again, as I said, the cybersecurity it must be taken into account in all space, in all the processes. And when it comes to dealing with CNS and ATM equipment, according to the regulation, only ATSEP are authorized to start and stop systems and processes, etc., etc. However, we need the cooperation offline and strategically of the IT personnel. And that's all. Thank you very much for the privilege.
Thank you, Theodore. It was very relevant. As I said, Theodore wanted to be also provocative on some aspects with his proposal. So thank you so much. It was only worthwhile that you'll be taking the floor. That being said, I do apologize for the 5 minutes delay, but I like to blame the audience for it. No, it's just that everybody was very interested, and I would like to thank the panelists that did an amazing job also addressing the questions, the concerns that were raised. Thank you also, Monica. Thank you, the colleagues from EUROCONTROL, for all the flexibility and coordination in setting up this meeting. Just two things from my side. I did not expect that today we will be actually making a link between incidents at defense, aviation, and atomic level. But I guess it's a lesson learned from the activities. It shows how much of cross-border and how wide actually artificial intelligence can be. And what I can say is that let's not forget that AI has to be addressed at all aspects. I think this was a topic that we try really to convey to you all, the human aspect, technological aspect, the defense aspect, cybersecurity. Those are all elements that we have to convey. And again, thank you so much to the panelists, and thank you to the terrific audience. Thanks.
So thank you, Enrico. Thank you for the speakers as well for my name. There's always to be one that has to be the worst one. So, hey, that was you. But if it's only 6 minutes, I think we can all live with that. So again, thank you very much. So it's time for the concluding remarks. The journey started for us in 2019. I would say our public journey. We have been dealing with some machine learning algorithms, etc., in the labs, but the way that we really came out when Eamon really insisted, Eamon Brennan, the DG of the time, that we would really have a go at artificial intelligence, etc., with our high-level conference. But there wasn't that much content yet, so there was lots of flashes and lights and spectacle, where movies, we did lots of things like that. But there wasn't, again, that much content. Then, under the very, I would say, very good leadership of Sylvie as well, we then wrote, together with the high-level group, the FlyAI report, which really had as a title, Demystification and Accelerating of AI. And if I now start to look at where we are today, I think it's more and more about acceleration and less about demystification. We're all starting to understand the topic very well. Then came the COVID years. We did webinars then. We also EUROCONTROL invented discovered the webinar. Thousands of people online, etc. But it was difficult for us to get a real feel of how the things were evolving. Then 2023, exactly 12 months ago, we did our first FlyAI Forum with a similar amount of people here in the room, a number of stands, etc. And we really thought, hey, we're onto something. There were a lot of new people that we normally wouldn't see, younger people, data scientists, etc., new applications coming around, etc. But last year, we still spent a lot of time, I don't know if you remember, talking about techniques, talking about terminology, confusing each other a little bit, etc. And I think all that has started to go away as well. So 2024, the second forum ever. We are talking now digital assistants. We're talking about teaming. Well, whether we like the term or not, we will see that later. We're having many more applications. So they keep on popping up everywhere. And they're really starting to impact our work. And we're starting to have discussions around that. And I think that really shows part of the maturity that we have on this. So I think it's fair to say that this was the best AI event ever. Yeah, at least the one that we have organized. We'll be back next year, so we'll see if we can outperform ourselves. We had more speakers, we had more topics, we had more moderators, we had more stands. It was bigger, it had a huge variety in terms of terminology. We had the defense angle this time, more on cyber. We had Meteo, the drones, etc. We had many more on our research and innovation. And thank you very much for the CZU colleagues for that, etc. So we really all together, I think, are starting to move this forward rightly. So AI is maturing at a rapid pace. The applications are evolving. We see it going in operations. The regulations and standards are evolving. It's not all going at the same speed. So we're sort of all together finding our way forward on this topic. But my message to you, keep going, keep pushing, keep sharing, keep learning like we've been doing these last 2 days. Again, I learned a lot and I saw a lot of people, unlike many other meetings where we're all hiding behind our laptop, etc. So a lot of people really glued to the screens of what was being shared, etc. So it was really good. Our support team will very soon show here on the screens a QR code. You can use that to fill in, please, the survey. We're always very keen to get your feedback on these type of events that we're organizing. If you are having to rush out of this meeting room, we will also send it by email to you together with information on the webpage, the recordings of all the different sessions, etc., the PowerPoints themselves, and again, a link to this survey. So our preference, of course, is that you fill it in now because it's all fresh. And we would like to finish the day with a lot of good, feeling good, and oh, look at this, or oh, look at that remark, etc. But otherwise, tomorrow is still fine for us as well. I would like to thank a lot of people. I would like to thank you, the speakers, the moderators, the stand holders, everybody, etc. It was fantastic to see. I would like to thank our support team in EUROCONTROL. They've done, again, a fantastic job. Guido standing there modestly at the back, Lucia, Claire, all the others there in the back, etc. Pascal, the people in the IT room, etc. But there is really one person that I need to thank really, that we all need to thank really from the bottom of our hearts. It's the person that not only does the timekeeping, she's also the one that really brought us all together. She's the one that contacted all of you, the different organizations, the speakers, quickly being totally overwhelmed by the number of people that wanted to speak, wanted to have a stand, and I want to do this and I want to do that, etc. But you very, very gently massaged it and worked it all in a way that everybody kept on smiling and was happy to come, etc. And that is no small achievement. I think, again, also it showed that you had been really well balancing all the different sessions, the different topics, etc. It really came out nicer than ever before. And for that, we have a little surprise for you. Ta-da! Yeah. So thank you very much. Thank you very much, Benjamin, for this as well. So our last message to you, we hope to see you all next year. For the people online, thank you very much for participating. For the people in the room, have safe travels home. And I think the most important message is have fun with AI. See you next year.